Hello, quiet traveler. Some nights when the world feels too loud, we look up. We search for something distant, something still. But what if I told you there's a place so far away that even sunlight arrives, tired, where two worlds dance together in near perfect darkness, locked in an embrace that's lasted billions of years? Tonight we're drifting to the edge of everything we know, to a moon that isn't quite a moon, to a dance that defies the rules, to Charon Pluto's dark companion, spinning in the frozen silence nearly 4 billion miles from home. Before we begin our journey into this quiet corner of the cosmos, if you find peace in these gentle explorations, you might like to stay a while. You can softly tap the like button, subscribe, if you'd like more stories whispered through the dark, and ring the bell, not for noise, but so the next quiet night can find you again. Now, let's drift. Picture this. Two spheres, gray and patient, turning in the blackness. One slightly larger one, slightly smaller. Most moons orbit their planets like children, circling a parent always at a distance, always separate. But Charon does something different, something scientists didn't expect to find. Charon doesn't orbit Pluto, the way our moon orbits Earth. Instead, they orbit each other like dancers holding hands spinning around a point in the empty space between them. They're so balanced, so perfectly matched in their gravitational pull that neither can claim to be the center. They share it. This changes everything we thought we knew about moons. In our solar system, most moons are small, distant companions. Our moon is roughly 1/80th the mass of Earth. Jupiter's Europa, one of the most fascinating moons we know, is barely 1/40,000th the mass of Jupiter. But Charon is 1/8 the mass of Pluto. That's enormous. That's unprecedented. That ratio is so extreme that many scientists quietly stopped calling them a planet and a moon. They started calling them something else, a binary system. Two worlds bound together, neither dominant, neither secondary, just together. Think about that for a moment. What does it mean to be neither planet nor moon, but both at once? The number itself tells a story, 1 to 8. For every 8 kilograms of Pluto, there's 1 kilogram of Charon. In the language of celestial mechanics, this is revolutionary. It means the center of their orbit, the barycenter, doesn't sit inside Pluto's core like it should. It floats outside in the space between them, about 580 miles above Pluto's surface. They don't spin around each other like a parent and child. They spin like partners, like equals, holding an invisible axis between them in the dark. Our moon pulls on Earth, yes. It creates tides, it stabilizes our axis, it lights our nights. But Earth remains the anchor. Earth is the dominant body. If you could watch from space, you'd see the moon circling us, and us barely wobbling in return. But if you watch Pluto and Charon, you'd see something that looks almost like a slow, frozen waltz. Two bodies visibly moving around a shared point, neither willing to let go. Scientists suggest this might be the most balanced large binary system in our entire solar system. Nothing else comes close. Saturn has Titan, massive and mysterious, but Titan is still only 2% of Saturn's mass. Neptune has Triton captured and strange, but Triton is only 1/5 of 1% of Neptune's mass. Mars has 2 tiny potatoes called Phobos, and Deimos barely worth mentioning. Only Pluto and Charon have achieved this. Only they have found this equilibrium in the outer dark. Some believe this makes them more like a double planet than anything else. A double dwarf planet, if we're being technical, because Pluto itself was reclassified in 2006, stripped of its planetary status, and given a new tidal dwarf planet. It was controversial then. It still stings for some people now. But Charon didn't care about the controversy. Charon kept dancing. Charon kept holding on. There's something poetic about that, isn't there? While humans argued about labels and categories about what counts as a planet and what doesn't, Charon simply continued doing what it's done for over 4 billion years. Existing, orbiting, being exactly what it is. And here's where the numbers become even stranger. They are tidally locked not just Charon to Pluto, but both to each other. Tidal locking is common enough in our solar system. Our moon shows us the same face always rotating once per orbit, so we never see its far side from Earth. But Pluto and Charon have achieved something rarer: mutual tidal locking. Pluto always shows the same face to Charon. Charon always shows the same face to Pluto. If you stood on Pluto's Charon-facing hemisphere, you'd see Charon hanging motionless in your sky, never rising, never setting, just hovering there like a pale gray guardian. And if you stood on the opposite side of Pluto, you'd never see Charon at all, not once in your entire life. It would be as if Charon didn't exist. The same is true in reverse. Stand on Charon's Pluto-facing side, and Pluto hangs there enormous and still. Stand on Charon's far side, and Pluto vanishes from reality. This is intimacy on a cosmic scale. This is what happens when two bodies pull on each other for so long that they synchronize, completely erasing all rotation, except the one they share. Their day is 6.4 Earth days long. Their orbit around each other is 6.4 Earth days long. Everything matches. Everything aligns. They breathe together in the silence. Do you ever feel that way with someone? Like you've orbited each other so long that you've synced, fallen into rhythm, stopped needing words? The mechanics of how this happens are well understood. Tidal forces, the same forces that pull our oceans into bulges, act like friction on rotating bodies. Over millions and billions of years, these forces slow rotation, transferring energy until the rotation period matches the orbital period. It's inevitable given enough time. The moon did it to itself 4 billion years ago. Pluto and Charon did it to each other, but mutual tidal locking is fragile. It requires the right mass ratio, the right distance, the right timing. Most systems never achieve it. Most partners never fully sync. But they did. From Earth, we can't see this dance with the naked eye. Pluto is too far too dim, just a point of light among millions. Even in our best telescopes, it was barely more than a blur for decades. But we knew Charon was there. We'd known since 1978. And in 2015, when the New Horizons spacecraft flew past after a 9-year journey, we finally saw them clearly. Two gray worlds close together, spinning in the dark. The images came back slowly, pixel by pixel, transmitted across billions of miles at the speed of light. And when scientists saw them, really saw them, they realized just how strange, how beautiful, how perfectly balanced this system truly was. Charon is roughly 750 miles across. Pluto is roughly 1,400 miles across. If you place them side by side, Charon would come up to about Pluto's shoulder. Not a child, not a satellite, but a sibling, a partner, a twin. And the distance between them: 12,163 miles center to center. That sounds like a lot, but in cosmic terms, it's nothing. The moon is 238,000 miles from Earth. Charon and Pluto could fit their entire orbit inside the space between us and our moon with room to spare. They are close, closer than almost any large moon and planet in the known solar system. Close enough that if you stood on one, the other would dominate your sky, filling it with gray detail, craters and canyons visible to the naked eye. Research shows that this closeness isn't stable forever. Tidal forces, the same ones that lock them together, are slowly, imperceptibly pushing them apart. It's happening at a rate too small to measure in a human lifetime, maybe a few centimeters per century, maybe less. But over billions of years, it adds up. One day in the unimaginably distant future, they might drift far enough apart that the lock breaks, that the synchronization fails, that they stop showing each other the same face. But that day is not today. That day is not for countless ages yet. For now, for all the time that matters to us, to our species, to our civilizations, they remain as they are, locked, dancing, together in the frozen outer dark. It seems as though the universe, for all its chaos and randomness, occasionally creates pockets of perfect stillness, systems that find balance and hold it, orbits that stabilize, dances that never end. Charon and Pluto are one of those pockets, a quiet miracle at the edge of the solar system where two worlds chose each other and have never let go. You don't need to understand all the mathematics to feel the beauty of it. You don't need to calculate barycentric coordinates or tidal dissipation rates to know that something profound is happening out there. Sometimes the universe just shows us what partnership looks like, what it means to find your match and hold on even in the coldest, darkest, loneliest part of space. Maybe that's why Charon matters. Not because it's large or close or tidally locked, though all those things are true, but because it reminds us that even at the edge of everything, nothing has to be alone. The ancient Greeks knew something about this, even if they didn't know about moons or dwarf planets or orbital mechanics. Charon in their mythology was the ferryman of the dead, the one who carried souls across the river, Styx into the underworld. Quiet, patient, necessary. Not a god, but a guide. Not powerful, but essential. Always there, always waiting, always moving between worlds. It's a fitting name. Because Charon the moon does exactly that. It guides Pluto through the darkness. It holds the balance. It reminds us that even in the underworld of the solar system, even in the realm of the forgotten and the distant, there is still connection, still gravity, still dance. And so, tonight we begin here, with two worlds gray and patient spinning together, where the sun is just a bright star among stars. With a partnership that has lasted longer than continents, longer than oceans, longer than anything human. With Charon, Pluto's dark companion, the moon that isn't quite a moon, the partner that never left. There's so much more to discover, canyons deeper than anything on Earth, colors that shouldn't exist in frozen methane, mysteries hidden beneath ancient ice. But, for now, just rest in this image. Two spheres turning slowly perfectly matched, holding each other in the endless night. We'll explore deeper soon. We'll drift into the canyons, into the red poles, into the secrets that Charon keeps. But first, let the ideas settle. Let the dance begin. But how did we find them? How did we discover this quiet partnership spinning at the edge of everything? Sometimes the greatest discoveries happen by accident. Sometimes what we think is a mistake turns out to be a truth we weren't ready to see. And sometimes, on a June evening in 1978, a man squinting at a photographic plate notices something that shouldn't be there. A bulge, a bump, a blur, and everything changes. His name was James Christie. He was an astronomer at the United States Naval Observatory in Flagstaff, Arizona, doing what astronomers do, measuring, calculating, trying to pin down the precise orbit of Pluto. Pluto had been discovered in 1930, and for 48 years, scientists had been trying to understand its movement across the sky. But something was off. The math didn't quite work. Pluto wobbled when it shouldn't. It moved in ways that didn't match predictions. So, they kept taking photographs, long exposure images on glass plates, hoping to refine the data to eliminate the errors to get it right. Christie was examining one of these plates on June 22, 1978. He was looking at an image of Pluto, or what was supposed to be Pluto, just a tiny point of light magnified until it became a small disk. But the disk wasn't round. It had a bump on one side, a slight elongation like someone had gently pressed their thumb into soft clay and left a mark. His first thought. The telescope was out of focus. The plate was flawed. The image was bad. This happens sometimes. Equipment malfunctioned. Atmospheric distortion blurred things. Photographic emulsions weren't perfect. He almost dismissed it, almost moved on. But something made him pause. Maybe it was curiosity. Maybe it was instinct. Maybe it was just the stubbornness of someone who spent too many nights staring at tiny dots of light and refusing to believe they're meaningless. He pulled other plates from the archive, other images of Pluto taken on different nights, different months, different years. And there it was again, the bulge. But it had moved. In some images it was on the left side of Pluto, in others on the right, in some at the top, in others at the bottom. It rotated, it changed position, it followed a pattern. This wasn't a flaw, this wasn't distortion, this was real. This was something orbiting Pluto, something large enough and close enough to show up on photographic plates as a merged blob with Pluto itself. This was a moon that had been there all along, invisible to everyone who looked hiding in plain sight for 48 years. Scientists suggest that this is one of the most profound lessons in astronomy. Sometimes we don't see things not because they're not there, but because we're not looking correctly. We assume our tools are wrong. We assume the image is bad. We assume the universe is behaving the way we expect it to behave. And in that assumption, we miss the truth sitting right in front of us. Christie didn't make that mistake. He looked closer. He measured the bulge's distance from Pluto's center. He tracked its movement across multiple plates. He calculated an orbital period 6.387 days. He calculated a distance roughly 12,000 miles. He ran the numbers again and again, checking for errors, checking for coincidences, checking for any reason this couldn't be real. But the data held. The bulge was consistent. The motion was regular. The mathematics worked. Pluto had a moon, a large one, and no one had known. Have you ever discovered something that was always there but somehow invisible until the moment you saw it? The announcement came quickly. By July, the discovery was confirmed by other observatories. By August, the moon needed a name. Tradition dictated that moons of planets should be named after figures from mythology related to the planet's namesake. Pluto was the Roman god of the underworld, so the moon should be a figure from that realm, someone connected to death, to the afterlife, to the crossing of boundaries between worlds. Christie thought of Charon, the ferryman, the quiet guide who rows the dead across the river Styx. Perfect, mythologically appropriate, symbolically resonant. But there was something else too. Something personal, something tender that no one expected from a scientific paper. Christie had another reason for the name. His wife's name was Charlene, her nickname Char. Pronounced almost the same as Charon in English. Charon, Charon, close enough. Close. He wanted to name the moon after her, to put her name in the sky, to make her part of the cosmos. The International Astronomical Union approved it, not because of the personal connection. They had no idea about that at first, but because Charon fit the mythological requirements. The name stuck, and so a moon discovered by accident was named both for ancient myth and for a 20th century woman in Arizona who probably never expected to have a celestial body bear her name. It seems as though the universe occasionally allows room for love in its catalog of stone and ice. But here's the part that makes this story even stranger. Charon wasn't hard to find because it was small or far away. It was hard to find because it was too close. Remember, Pluto and Charon are only 12,000 miles apart, center to center. From Earth, even through powerful telescopes, that distance is almost nothing. Pluto is roughly 3.6 billion miles away at its closest approach to us. At that distance, resolving two objects only 12,000 miles apart is like trying to see two grains of sand side by side from 10 miles away. The human eye can't do it. Most telescopes couldn't do it in 1978. They merged into a single blob, a single point of light, inseparable. Only long exposure photography magnified and carefully examined revealed the slight elongation, the subtle bump, the hint that something else was there. If Charon had been farther from Pluto, if their orbit had been wider, if their dance had more space, we would have discovered it decades earlier. But because they're so close, because they hold each other so tightly, they hid from us. They looked like one thing when they were always two. Think about that. The very closeness that makes them special, that creates their mutual tidal lock, that forms their binary dance, also made them nearly invisible to us. Intimacy, even on a cosmic scale, sometimes looks like solitude from the outside. Some believe this is why we miss so much about the outer solar system for so long. We were looking with tools designed for brighter, closer, more obvious things. We were searching with expectations built on what we already knew: Jupiter's moons, Saturn's rings, Mars's polar caps. But the outer solar system doesn't play by those rules. It's darker, colder, stranger. Things hide not because they want to, but because distance and darkness erase details. Because photons take hours to arrive. Because reflected sunlight from Pluto is roughly 1,600 times dimmer than sunlight reflected from Earth's moon. Charon was always there, patient and gray, circling Pluto in the frozen silence. But we weren't ready to see it. Not until Christie squinted at that plate and refused to believe the bump was a mistake. The discovery changed everything. Suddenly, Pluto wasn't alone. Suddenly, the ninth planet, the oddball at the edge, had a companion. And that companion was big, too big to ignore. 2. When scientists calculated Charon's mass using its orbital period and distance, they realized it was roughly 1/8 of Pluto's mass. That ratio shocked them. That ratio broke expectations. Nothing else in the solar system looked like this. It forced astronomers to reconsider what Pluto was, what Charon was, how they formed, why they stayed together. It opened questions that still don't have complete answers today. But more than that, it reminded everyone in the field of a simple truth. We don't know everything. We haven't seen everything. The universe is full of surprises, and some of them are hiding in plain sight, waiting for someone stubborn enough to look twice at a blurry photograph. Research shows that many of the most important astronomical discoveries happen this way. Not through grand missions or billion-dollar telescopes, though those matter too, but through persistence. Through someone noticing a detail that everyone else dismissed. William Herschel discovered Uranus in 1781 because he saw a disk instead of a point and refused to assume it was a comet. Clyde Tombaugh discovered Pluto in 1930 by comparing photographic plates and noticing a dot that moved. Vera Rubin discovered dark matter by measuring galaxy rotation curves and refusing to ignore the data when it didn't make sense. Christie discovered Charon by staring at a bump and deciding it mattered. There's a lesson in that, a quiet one. The universe doesn't always announce its secrets. Sometimes it whispers them in the form of anomalies, glitches, things that don't quite fit. And if we're too quick to smooth over the rough edges to correct the errors to make the data match our expectations, we miss the truth. Mistakes aren't always mistakes. Sometimes they're invitations. Sometimes they're the universe saying, look closer, pay attention. I'm showing you something. And Christie did. He looked closer, he paid attention, and he found a moon that had been waiting 48 years to be seen. By the early 1980s, more observations confirmed everything. Charon's orbit was circular, stable, perfectly synchronized with Pluto's rotation. Its surface appeared gray and neutral, lacking the reddish tint that Pluto showed. Spectroscopic analysis suggested water ice, lots of it, covering Charon's surface, while Pluto's surface was dominated by nitrogen, methane, and carbon monoxide ices. They were made of different things. They had different densities. They weren't twins, not in composition. But they were bound together, gravitationally inseparable, locked in their mutual orbit for billions of years. The discovery also helped solve the wobble problem. Remember, Pluto's orbit didn't quite match predictions, but that's because astronomers had been calculating Pluto's mass wrong. They'd been treating Pluto as a single object, when it was actually two objects, a binary system. When they recalculated using Pluto's mass alone minus Charon's contribution, the orbit made sense. The wobble disappeared. The math worked. Charon, by existing, fixed the problem. It seems as though sometimes the answer to a mystery isn't new information, but seeing old information correctly. Pluto hadn't changed. Its orbit hadn't changed. What changed was our understanding, our willingness to see two where we'd assumed one. And in that shift, clarity emerged. By 2006, when the International Astronomical Union reclassified Pluto as a dwarf planet, the debate about Charon resurfaced. Some scientists argued that Charon should be considered a moon of a dwarf planet, Others argued that the system should be classified as a binary dwarf planet, two objects of comparable size orbiting a common center. The official decision left it ambiguous. Charon is Pluto's moon, but the system could also be considered binary. Both are true. Both matter. Language struggles to keep up with reality sometimes. But Charon doesn't care about human classifications. It keeps orbiting. It keeps dancing. It keeps doing what it's done since the solar system was young and Earth was still molten. And here's the beautiful part: none of this would have happened without patience. Without someone taking the time to compare old photographs, to track subtle changes, to refuse the easy answer. Christie didn't have computer algorithms or AI-enhanced imaging. He had glass plates, a magnifying lens, and a hunch. That was enough. It's a reminder that discovery isn't always about having the best tools or the biggest budgets. Sometimes it's about attention, about care, about being willing to sit with a question long enough for the answer to reveal itself. Charon revealed itself on June 22, 1978, and nothing about Pluto or the outer solar system or our understanding of how moons and planets interact has been the same since. Now that we know Charon exists, now that we've seen it clearly, thanks to New Horizons, now that we understand its size and its strange balanced relationship with Pluto, we can ask deeper questions. Questions about its surface, about the scars it carries, about the secrets frozen in its ice. What does it mean to orbit together rather than around each other? Imagine two ice skaters holding hands, spinning in perfect unison. Neither is the center. Neither pulls harder. They've found a point between them, invisible but real, and they rotate around it as one. This is not how most planets and moons work. This is not how Earth and our moon dance. But this is exactly how Pluto and Charon move through space. And once you understand this dance, you begin to see why their relationship is unlike anything else we've found. The mathematics are elegant but profound. When two objects orbit in space, they don't actually orbit each other in the way we casually describe. They both orbit their common center of mass, called the barycenter. For most planet-moon systems, this center lies deep inside the larger body. Earth and our moon, for example, orbit a barycenter that sits about 1,000 miles beneath Earth's surface. The moon goes around us in a wide circle, and we wobble slightly in response, but the wobble is so small that for practical purposes, we say the moon orbits Earth. We are the anchor. We are the dominant mass. But Pluto and Charon break this pattern. Their barycenter, the invisible point they both circle, lies in empty space between them. Specifically, it floats about 580 miles above Pluto's surface, well outside Pluto's physical body. This changes everything. It means when you watch them from a distance, you don't see a moon orbiting a planet. You see two objects visibly rotating around a shared point in the void. Neither is stationary. Neither stays still. They both move. They both contribute equally to the dance. Scientists suggest this is the defining characteristic of a true binary system. When the barycenter lies outside both bodies, when neither object dominates gravitationally, the system stops behaving like a planet with a satellite and starts behaving like two partners locked in mutual orbit. And in our solar system, among the larger bodies we've studied, Pluto and Charon are the clearest example of this phenomenon. Why does this happen? Why are they so balanced when almost nothing else is? The answer lies in mass ratio. Charon is roughly 1/8 the mass of Pluto. That number 1:8 is extraordinary. Our moon is 1/80th the mass of Earth. Titan, Saturn's largest moon, is about 1/50th the mass of Saturn. Triton, Neptune's strange captured moon, is less than 1/200th the mass of Neptune. Even Ganymede, the largest moon in the entire solar system, is only 1/12,000th the mass of Jupiter. None of them come close to Charon's ratio. None of them shift the barycenter into open space. Charon does. And because of that, Pluto wobbles visibly as it orbits the Sun. If you could watch from outside the solar system with a powerful enough telescope, you'd see Pluto trace a wavy path through space, oscillating back and forth every 6.4 days, as Charon pulls it around their shared center. The wobble is real. The dance is undeniable. This is not a planet with a moon. This is two worlds bound together, spinning as one. Some believe this makes them more like a double dwarf planet system than a traditional planet-moon pair. The International Astronomical Union has discussed this classification multiple times. Should we call Charon a moon, or should we call both of them components of a binary system? The official answer remains ambiguous. Charon is listed as Pluto's moon in most databases, but many planetary scientists quietly refer to the system as binary. Language struggles when reality doesn't fit neat categories. But here's what makes their dance even more remarkable. They are mutually tidally locked. Not just Charon locked to Pluto, as our moon is locked to Earth, but both locked to each other. Tidal locking happens when gravitational forces slow a rotating body until its rotational period matches its orbital period. Our moon did this billions of years ago. It rotates once every 27.3 days, the same time it takes to orbit Earth, so the same side always faces us. We call it the near side. The other half, the far side, remains perpetually hidden from Earth's surface. But Pluto and Charon have achieved something rarer and more symmetrical: mutual tidal locking. Pluto rotates once every 6.4 days. Charon orbits Pluto once every 6.4 days. Charon rotates once every 6.4 days. Everything syncs, everything matches. If you stood on Pluto's surface facing Charon, Charon would hang motionless in your sky, never moving, never setting, just hovering there like a pale gray moon frozen in position. Days would pass, weeks would pass, years would pass, and Charon would remain exactly where it is locked, to the same point above the horizon. And if you walk to the opposite hemisphere of Pluto, the side facing away from Charon, you would never see Charon at all. Not once. Not ever. It would be as if Charon didn't exist. The same is true in reverse. Stand on Charon facing Pluto, and Pluto dominates your sky, motionless and enormous. Stand on Charon's far side, and Pluto vanishes completely. Have you ever been so connected to someone that you forgot where you ended and they began? This kind of mutual lock is incredibly rare. It requires specific conditions. The two bodies must be close enough for tidal forces to be strong. Their masses must be similar enough that both experience significant tidal drag, and they must have enough time for the tidal dissipation to slow both rotations completely. Most systems never achieve this. Earth and the Moon will eventually reach mutual tidal lock, but not for billions of years long after the Sun has begun dying. Mars's moons, Phobos and Deimos, are too small to lock Mars. Jupiter's moons are too light to affect Jupiter's rotation at all. Only Pluto and Charon, with their close proximity and unusual mass ratio, have already reached this perfect equilibrium. Research shows that mutual tidal locking is a stable end state for binary systems. Once achieved, it tends to persist indefinitely, barring external disturbances like collisions or close encounters with other massive objects. Pluto and Charon reached this state billions of years ago, possibly within the first few 100 million years after their formation. And they've stayed locked ever since, rotating together in perfect synchrony, neither gaining nor losing energy to the other, just holding their rhythm in the frozen dark. It seems as though the universe occasionally creates pockets of permanence relationships that stabilize and hold orbits that find balance and refuse to break. Pluto and Charon are one of those pockets. A partnership that has lasted longer than mountains, longer than oceans, longer than any bond we can imagine on human timescales. But mutual tidal locking has consequences. It shapes how the system behaves, how energy moves between the two bodies, how their surfaces evolve over time. Tidal forces, the same forces that created the lock, are generated by gravity acting unevenly across an object. The side of a moon facing its planet feels slightly stronger gravity than the far side, creating a stretch, a bulge, a deformation. On bodies that rotate relative to their orbit, this bulge moves, creating friction, generating heat, slowing rotation. Earth's tides, the daily rise and fall of oceans, are caused by the moon's gravity creating these bulges in our water. The moon pulls the oceans toward it, creating high tide, while centrifugal force creates another high tide on the opposite side. As Earth rotates beneath these bulges, friction slows our rotation by about 1.7 milliseconds per century. Not much, but over billions of years it adds up. The moon, in turn, is slowly drifting away from Earth, moving about 1.5 inches farther each year as it absorbs the rotational energy Earth loses. Eventually, far in the future, Earth's rotation will slow until one side permanently faces the moon and both will be mutually locked. But that day is unimaginably distant. Pluto and Charon have already arrived there. They've finished the process, and now, locked together, tidal heating has mostly ceased. There's no more friction, no more energy dissipation, no more internal warmth generated by tidal flexing. They've become cold static, frozen in their mutual gaze. This matters because tidal heating is one of the primary ways small icy bodies stay geologically active. Europa, one of Jupiter's moons, has a subsurface ocean kept liquid by tidal heating from Jupiter's immense gravity. Enceladus, one of Saturn's moons, has geysers of water ice erupting from its south pole powered by tidal friction. Io, Jupiter's innermost large moon, is the most volcanically active body in the solar system because tidal forces from Jupiter constantly knead its interior like dough, generating enormous heat. But Charon has none of this. Charon is tidally dead. Its interior is cold, frozen solid, no longer churning or convecting or generating heat from gravitational friction. Whatever geological activity it once had ended long ago, perhaps a billion years after formation, perhaps longer. Now, it's just ice and rock cold, and still shaped only by ancient processes and occasional impacts from passing debris. Some believe this is why Charon's surface looks so old, so cratered, so heavily scarred. Without tidal heating to drive cryovolcanism or tectonic activity, there's no way to erase or renew the surface. Craters accumulate, ice fractures slowly over eons. The landscape becomes a record of every impact, every collision, every scar preserved in the deep freeze of the outer solar system. Pluto, by contrast, shows signs of relatively recent geological activity. Its famous heart-shaped region, Tomball Regio, has very few craters suggesting the surface was renewed within the last 10 million years, maybe even more recently. How we're not entirely sure. Pluto doesn't have significant tidal heating either, not anymore. But it might have internal radioactive decay, residual heat from formation, or convective processes in its nitrogen ice layer that allow the surface to renew itself occasionally. Charon lacks even this. Charon is older, colder, quieter. But there's beauty in that quietness. There's something profound about a world that has finished changing, that has reached its final form, and simply rests. Charon is not trying to be anything other than what it is. It's not erupting, not shifting, not convecting. It's just there, gray and patient, carrying its scars, openly holding its orbit perfectly. The distance between them, center to center, is 12,163 miles. That's close. Extraordinarily close by cosmic standards. If you place them next to Earth and the Moon, their entire orbit would fit comfortably inside the gap. The Moon orbits Earth at an average distance of 238,000 miles. Charon orbits Pluto at 1/20th that distance. Closeness on this scale creates intimacy. If you stood on Pluto's near side, Charon would appear roughly 8 times larger in your sky than our moon appears from Earth. It would dominate the horizon, a vast gray disk covering a significant portion of the sky so close you could see surface details, with the naked eye craters, canyons, plains, ridges. You could watch shadows shift slowly across its surface as Pluto's dim sunlight moves, though calling it sunlight feels generous. At that distance, the sun is just a bright star, no larger than Venus appears from Earth, providing only 1/1600th the light Earth receives. But still there would be shadows. There would be contrast. There would be detail. And Charon would never move. Hour after hour, day after day, year after year, it would hang there fixed in position, a constant presence in your sky. Some nights you might find comfort in that. Some nights the unchanging moon might feel like a companion, a guardian, a reminder that not everything in the universe is chaos and flux. Other nights it might feel suffocating, oppressive, a reminder that you're locked in place, unable to see beyond your hemisphere, unable to experience the full sky. But Charon wouldn't care. Charon would just be there holding its gaze, reflecting faint sunlight, back at you, dancing the only dance it knows. Research shows that mutual tidal locking also means Pluto and Charon experience no eclipses from each other anymore, not in the way we think of eclipses. Because they're locked, certain regions of Pluto never see Charon pass in front of the sun, and certain regions of Charon never see Pluto block the sunlight. The geometry is fixed. The angles don't change. If you're standing in a location where Charon transits the sun, from your perspective, it will always transit the sun from that location. If you're standing where it doesn't, it never will. The universe becomes predictable, stable, geometric. Is that peace or is that imprisonment? Maybe it's both. Maybe it depends on how you look at it. What we do know is this: Pluto and Charon have found something almost no other bodies in the solar system have found. True balance, true partnership. A dance where neither leads, neither follows, both simply move together. And that dance, quiet and cold and impossibly distant, continues even now as we speak. 6.4 days per orbit, 12,000 miles apart. Locked together for 4 billion years and counting. They are not alone, but they are isolated. Far from the sun, far from the inner planets, far from the noise and heat and chaos of the solar system's crowded center. Out there in the Kuiper Belt, surrounded by ice and darkness and the faint glow of distant stars, they turn together, patient, steady, unbreakable. And we, billions of miles away, can only watch and wonder what it means to be so perfectly, so completely, so eternally bound to another world. But perfection even in orbit carries secrets, and Charon's surface holds mysteries that mutual tidal locking cannot explain. What if I told you that one of the most dramatic landscapes in the entire solar system exists on a moon? Most people have never heard of deep gashes, walls of ice rising miles into the sky, canyons so vast they could swallow mountain ranges whole. This is not Mars. This is not Venus. This is Charon, the quiet moon we thought was boring. The gray companion we assumed was just another cratered ball of ice, until July 14th, 2015, when New Horizons flew past and showed us the scars, and suddenly boring became breathtaking. If you're finding these quiet journeys through space meaningful, you might want to gently tap the like button, subscribe to continue drifting with us through the cosmos, and ring the bell so these stories can find you again when the night feels wide. Now, let's descend into the canyons. Before New Horizons, we knew almost nothing about Charon's surface. We had fuzzy images from Hubble, barely enough to show dark and bright patches, hints of variation, suggestions that something was there. But detail, topography, geology. We had nothing. Charon was just a gray dot, tidally locked to Pluto, presumably ancient and inactive. Scientists expected craters, lots of craters, maybe some fractures from ancient tidal stresses, but mostly just a dead frozen surface unchanged for billions of years. A museum of impacts. A graveyard of geological time. They were wrong. When New Horizons sent back the first high-resolution images of Charon's surface, Planetary scientists saw something they didn't expect. Canyons. Not small cracks or gentle valleys, but enormous, deep, complex canyon systems cutting across the equatorial and mid-latitude regions like wounds carved into ice. The largest of these systems is called Serenity Chasma, named after the fictional spaceship from the TV show Firefly. It stretches across Charon's surface for roughly 1,000 miles longer than the distance from New York to Miami. And it's deep, spectacularly deep. At certain points, Serenity Chasma plunges more than 5.5 miles below the surrounding terrain. 5.5 miles, straight down. Walls of water ice frozen harder than steel at those temperatures, dropping into shadow depths, where sunlight already faint at Pluto's distance barely penetrates at all. To put that in perspective, let's compare it to Earth's Grand Canyon, one of the most iconic geological features on our planet. The Grand Canyon, carved by the Colorado River over millions of years, reaches a maximum depth of just over 1 mile at its deepest point. Impressive by Earth standards, stunning to stand at the rim and look down. But Charon's Serenity Chasma is 5.5 miles deep, more than 5 times deeper than the Grand Canyon. If you stood at the rim of Serenity Chasma and looked down, you'd be staring into an abyss that makes Earth's grandest canyon look like a modest ditch. And Serenity Chasma isn't alone. There's another major canyon system called Argo Chasma, named after the ship from Greek mythology that carried Jason and the Argonauts. Argo Chasma runs for roughly 430 miles and reaches depths of over 5 miles in some sections. Then there's Manjet Chasma, smaller but still significant, cutting through the northern regions. And there are dozens, perhaps hundreds of smaller fractures, faults and rifts crisscrossing Charon's surface, creating a network of canyons that suggests something violent happened here, something that tore Charon's crust apart and left it scarred forever. Scientists suggest these canyons are tectonic in origin. Tectonic meaning they were created by the movement and fracturing of Charon's icy crust, not by erosion or flowing water or wind. Charon has no atmosphere to speak of, just trace amounts of methane and possibly nitrogen, far too thin to create weather or erosion. And Charon has no liquid water, no rivers, no glaciers that could carve valleys over time. The surface temperature hovers around -390 degrees Fahrenheit. At that temperature, water ice behaves like solid rock. It doesn't flow. It doesn't melt. It just sits there frozen and rigid unless something forces it to break. So, what broke Charon's surface so violently? What created canyons deeper than anything on Earth? The leading theory involves Charon's early history, back when it was still young and geologically active. Research shows that Charon likely had a subsurface ocean shortly after its formation, a layer of liquid water sandwiched between its rocky core and its icy outer shell. This might sound strange for a moon so far from the sun, but early in the solar system's history, all the icy bodies were warmer. They had heat from their formation, heat from radioactive decay in their cores, and possibly heat from tidal interactions before they became tidally locked. For a few 100 million years, maybe even 1 billion years, Charon's interior was warm enough to keep water liquid beneath the crust. But over time, that heat faded. The core cooled. The radioactive elements decayed. The tidal heating stopped once Pluto and Charon locked into synchronous rotation. And slowly, inevitably, the subsurface ocean began to freeze. When water freezes, it expands. You've probably seen this in your own freezer. A bottle of water left in the cold swells and cracks as the ice takes up more space than the liquid did. The same thing happens on planetary scales, but the consequences are far more dramatic. As Charon's ocean froze from the bottom up and the top down, the expanding ice pushed outward against the crust. Pressure built. Stress accumulated. And eventually the crust couldn't hold. It fractured. It split. Enormous faults opened up, creating the canyon systems we see today. Serenity, Chasma, Argo, Chasma, Manjet, Chasma. These aren't river valleys or impact scars. They're extensional faults, places where Charon's surface literally pulled apart under the stress of its freezing interior. Some believe this makes Charon a textbook example of what planetary scientists call cryotectonic activity tectonics, driven by the freezing and expansion of subsurface liquids. It's not unique to Charon. Europa, one of Jupiter's moons, shows similar fractures and ridges, though Europa's ocean is still liquid kept warm by tidal heating. Enceladus, one of Saturn's moons, has tectonic features driven by a subsurface ocean that occasionally erupts through the surface as geysers. But Charon's canyons are older, deeper, more dramatic. They're the frozen record of a world that once had liquid water and lost it. A world that cracked open as it cooled and never healed. It seems as though ice, despite being cold and still and seemingly inert, carries its own violence, its own memory of transformation. When water becomes ice, it doesn't just change state. It changes volume, and in doing so, it reshapes everything around it. On Earth, we see this in small ways, pipes bursting in winter rocks, splitting along fractures filled with frozen water. On Charon, we see it on a scale that dwarfs anything terrestrial. Entire regions of the crust pulled apart, creating canyons miles deep and hundreds of miles long. But there's another possibility, one that scientists haven't ruled out. These canyons might also have been influenced by an ancient impact. Remember, Charon likely formed from a giant collision between Pluto and another Kuiper Belt object billions of years ago. The impact would have been catastrophic, ejecting material into orbit that eventually coalesced into Charon. And impacts that large don't just create moons. They also create shockwaves, fractures, weaknesses in the crust that can persist for billions of years. It's possible that some of Charon's canyon systems follow fracture lines created during its formation, stress zones, that were always weaker than the surrounding crust. When the interior began to freeze and expand, these pre-existing weaknesses became the paths of least resistance, the places where the crust gave way first. Think about old wounds, how they ache when the weather changes, how they never quite heal the way undamaged skin does. Charon's canyons might be like that, ancient injuries from its violent birth reopened and deepened by later processes, scars layered on top of scars. And here's what makes these canyons even more fascinating. They're asymmetric. They don't circle Charon's equator evenly or radiate from a single point. Instead, they cluster in certain regions primarily around the equatorial belt and the sub-Pluto hemisphere, the side that always faces Pluto. The side that never sees Pluto-Charon's far side has fewer large canyons and more heavily cratered terrain. Why, scientists aren't entirely sure. It might be related to tidal stresses from Pluto's gravity, which would have been strongest on the near side before tidal locking was complete. Or it might be coincidence, just the random distribution of where the crust happened to be weakest when the freezing began. Or it might be evidence of something else we haven't figured out, yet some process or event unique to Charon's history that left its mark more strongly on one hemisphere than the other. Some research suggests that the canyons might also have been shaped by the way Charon's crust fractured as it expanded. Computer models of icy moon tectonics show that when a subsurface ocean freezes, the expansion doesn't happen uniformly. Some areas crack, first releasing pressure, which then redirects stress to other areas. The result is a complex branching network of faults and rifts, not a simple radial pattern. Charon's canyons fit this model. They branch, they intersect, they create polygonal patterns in some regions, long linear faults in others, chaotic jumbles of fractured terrain in still others. It's the fingerprint of a crust that broke slowly, unevenly over millions of years as the interior froze solid. But here's the mistake people often make. When they hear about these canyons, they assume Charon is geologically active now. They imagine cryovolcanoes, erupting tectonic plates, shifting new canyons forming. That's not the case. Charon is geologically dead. It has been for billions of years. The canyons we see were carved long ago, probably within the first billion years of Charon's existence, and they haven't changed significantly since. No new faults are opening. No old ones are deepening. Charon's interior is now completely frozen, a solid ball of ice and rock with no liquid layer, no convection, no internal heat source to drive geological activity. The canyons are fossils, beautiful, dramatic fossils, but fossils nonetheless. Frozen in time, preserved in the deep cold of the outer solar system, where nothing erodes, nothing weathers, nothing changes, except when an occasional meteorite strikes the surface. And even those impacts are rare. Charon orbits in the Kuiper Belt, a region of the solar system with far less debris than the inner solar system. Fewer asteroids, fewer comets crossing through. Collisions happen, but infrequently. The cratering rate on Charon is low, which means the canyons we see today look almost exactly as they did when they formed, give or take, a few new impact craters and some gradual slumping of canyon walls over geologic time. Scientists studying the New Horizons images measured the slopes of the canyon walls, the angles of the faults, the depth-to-width ratios. They found evidence of landslides, ancient avalanches of ice that tumbled down into the canyon floors billions of years ago and then froze in place. They found terraced walls, step-like features created as different layers of Charon's crust, fractured at different depths. They found fault scarps, cliffs, formed where one section of crust dropped relative to another. Every feature tells part of the story. Every detail adds a piece to the puzzle of how Charon's surface evolved. But one thing is clear, Charon's canyons are among the most dramatic tectonic features in the outer solar system. They rival the canyon systems on Mars, the rift valleys on Venus, the fault zones on Earth. And they exist on a moon most people thought was boring, a moon we almost didn't visit. If New Horizons hadn't been built, if the mission hadn't been funded, if the spacecraft hadn't survived its 9-year journey through space, we would still think Charon was just a gray, cratered ball of ice. We would never know about Serenity Chasma or Argo Chasma. We would never see the frozen architecture carved into its surface. We would miss the beauty entirely. That's the lesson here. Boring is often just a failure of imagination, or a lack of data. When we look at distant worlds through fuzzy telescopes, we see blobs and assume simplicity. But when we send spacecraft, when we get close enough to see details, we discover complexity, drama, stories written in stone and ice. Charon looked boring until we looked closely. Now it's one of the most geologically interesting moons we've studied. And that should make us wonder, how many other worlds are we dismissing as uninteresting simply because we haven't seen them clearly yet? How many other moons, asteroids, Kuiper Belt objects are hiding, secrets we can't imagine? The canyons of Charon are a reminder that the universe is generous with its wonders. Even at the edge of the solar system, even on a moon tidally locked to a dwarf planet, even in the frozen darkness where the sun is just a distant star, there is beauty. There is violence. There is history carved into ice and preserved for anyone willing to look. And Charon has more to show us, because the canyons are just the beginning. Imagine a world where the North Pole is stained the color of dried blood, not rust, not sand, not the warm reds of Mars or the pale pinks of sunset, but a dark, deep, almost bruised red that spreads across the top of the world like a shadow that refused to leave. This is Mordor Macula Charon's mysterious polar cap, and it's one of the strangest features in the entire outer solar system. And no one expected it to be there. If these quiet explorations into the far corners of space bring you peace, you might gently tap the like button, subscribe to keep journeying with us, and ring the bell so the next story can drift to you softly when the night feels right. Now, let's step into the red darkness. When New Horizons approached Charon in 2015, scientists were watching for gray. Charon's spectrum, analyzed from Earth-based telescopes, suggested a surface dominated by water, ice neutral in color, reflecting light evenly across most wavelengths. Maybe some slight variations in brightness, maybe some darker patches where ancient craters concentrated. But overall, they expected Charon to look like most icy moons, pale, gray, monotonous. Instead, the images revealed something no one predicted. Charon's North Pole was red, deeply, unmistakably red. Not the entire hemisphere, just the polar region, a cap of reddish-brown material covering roughly the top 15 to 20 degrees of latitude. The feature was so striking, so unexpected, that the science team immediately nicknamed it Mordor, after the dark land in Tolkien's Lord of the Rings. The name stuck. Officially, it's called Mordor Macula, with macula meaning spot or patch in Latin. But everyone still calls it Mordor, because that's what it looks like, a dark, ominous region sitting at the top of a frozen world, refusing to blend in with the surrounding ice. Scientists suggest the color comes from organic molecules called tholins, complex compounds, formed when simpler chemicals are exposed to ultraviolet radiation or cosmic rays. Tholins are common throughout the outer solar system. Titan, Saturn's largest moon, has an atmosphere thick with tholins, giving it a hazy orange appearance. Pluto's surface has reddish regions rich in tholins, particularly around its equator. But Charon's tholins are different. They're concentrated at the pole, they're darker. And they didn't form on Charon originally, they came from Pluto. Here's how it works. Pluto has a thin atmosphere, mostly nitrogen with traces of methane and carbon monoxide. During Pluto's summer, when its orbit brings it slightly closer to the Sun, some of this atmosphere sublimates, rising from the surface into space. But Pluto's gravity is weak. It can't hold on to everything. Some of the atmospheric gases escape, drifting away from Pluto into the space around it. And because Charon is so close, only 12,000 miles away, some of that escaping gas reaches Charon's surface. Methane in particular makes the journey. It's light, it moves fast, and it doesn't take much energy to escape Pluto's gravity. When methane molecules land on Charon, they don't just sit there. Charon's surface is cold, averaging around minus 390 degrees Fahrenheit, cold enough to freeze methane solid. But Charon's poles are even colder. Why? Because of something called a cold trap. Charon's rotational axis has a slight tilt, about 2.7 degrees relative to its orbit. Not much, but enough that the poles receive even less sunlight than the rest of the already dark surface. At the poles, temperatures drop to the absolute coldest. Charon can reach creating regions where volatile gases like methane preferentially condense and freeze. Think of it like frost forming on the coldest part of a window. The methane from Pluto drifts across spacelands randomly on Charon's surface, but over time, through sublimation and migration, it accumulates at the poles, where it's cold enough to stay frozen year-round, or rather, Charon year-round, which is 6.4 Earth days. But methane doesn't stay methane forever. Once it's trapped at the pole, it's exposed to ultraviolet light from the distant sun, and to high-energy particles from cosmic rays streaming through space. These forms of radiation break the methane molecules apart, splitting them into smaller fragments. Hydrogen atoms, carbon atoms, free radicals. And these fragments don't just float away, they recombine, forming new, more complex molecules. Ethane, ethylene, acetylene, propane, polymers. Eventually, if enough time passes and enough radiation bombardment occurs, these molecules link together into long chains and branching structures, creating tholins. Tholins are reddish-brown because they absorb blue and green light strongly while reflecting red and orange wavelengths. They're not a single molecule, but a class of organic compounds, a messy mixture of hydrocarbons and nitriles and other complex carbon-based structures. Research shows that tholins form easily in laboratory conditions when you expose simple gases like methane, nitrogen, and carbon monoxide to ultraviolet light or electrical discharges. Scientists have recreated the process in chambers designed to simulate Titan's atmosphere, Pluto's surface, even the early Earth before life emerged. The chemistry is well understood. Methane plus energy equals tholins given enough time. On Charon, that time has been billions of years. The methane has been arriving slowly, molecule by molecule, freezing at the poles, breaking apart under radiation, recombining into tholins accumulating in layers. The process is ongoing. Even now as we speak, methane is escaping Pluto, landing on Charon, freezing and transforming. Mortar macula is not a fossil. It's actively being renewed slowly but continuously as long as Pluto has an atmosphere and Charon has cold poles. Some believe this makes Charon a unique laboratory for studying prebiotic chemistry. Tholins are often called the building blocks of life, though that's a bit of an overstatement. They're organic, yes, meaning they contain carbon. But organic doesn't mean alive. Tholins aren't life. They're just complex molecules that, under the right conditions, might serve as raw material for biochemistry. On early Earth before life began, tholins might have existed in the atmosphere, raining down onto the surface, providing the organic compounds that eventually assembled into amino acids, nucleotides, and other biomolecules. On Titan, tholins are everywhere, forming a thick orange haze and settling onto the surface where they might interact with liquid methane lakes. On Charon, tholins sit frozen at the pole, exposed to vacuum and radiation, chemically inert but scientifically fascinating. They're a record of what happens when simple gases meet energy and time, a demonstration that complexity can emerge from simplicity without intention, without design, just through the patient accumulation of chemical reactions. It seems as though the universe has a tendency toward complexity. Left alone, long enough simple systems evolve into intricate ones. Hydrogen becomes helium, becomes carbon, becomes methane, becomes tholins, becomes who knows what, given the right conditions and enough time. Charon's red pole is a small example of that tendency, a reminder that even in the frozen outer dark chemistry continues. Transformation persists. But there's something else strange about Mordor macula. The tholins are darker than they should be. When scientists create tholins in the lab by irradiating methane, the resulting material is reddish. Yes, but relatively bright, reflecting maybe 20 to 30% of the light that hits it. Charon's Mordor region reflects only about 5 to 10% of incident light. It's much darker, almost black-red like old blood dried on stone. Why one possibility is that the tholins on Charon have been exposed to radiation for much longer than lab samples, allowing the molecules to cross-link further, polymerizing into even more complex, darker structures. Another possibility is that the tholins are mixed with other materials, perhaps water ice contaminated with ammonia or other compounds that darken when irradiated. Or it might be that Charon's tholins are thicker than expected, layered over time into deep deposits that absorb light more efficiently than thin coatings. Scientists don't know for certain. The New Horizons flyby was brief, just a few hours of close observation, not enough to do detailed compositional analysis of the polar region. We have images, we have color data, we have spectra showing the presence of water ice and hints of methane, but we don't have samples. We can't dig into Mordor macula and see how deep it goes or what's mixed in. We can only infer, model, hypothesize. And here's the part that challenges our intuition. Mordor macula is asymmetric. It's concentrated on the North Pole, but the South Pole shows much less reddish coloration. Why would one pole trap methane and form tholins while the other doesn't? The answer might lie in Charon's axial tilt and its orbital relationship with Pluto. Remember, Charon is tidally locked, always showing the same face to Pluto. But it also has that slight axial tilt, 2.7 degrees. Over the course of Pluto's orbit around the Sun, which takes 248 Earth years, different parts of Charon's surface experience varying amounts of sunlight. During part of Pluto's orbit, Charon's North Pole is tilted slightly toward the Sun, receiving more light. During another part, it's tilted away, plunged into decades-long darkness. The South Pole experiences the opposite pattern. These variations might affect how methane accumulates and transforms. If the North Pole spends more time in shadow during critical periods when methane is escaping from Pluto, it might trap more methane and develop a thicker, darker layer of tholins. Or it might be that the North Pole has been accumulating tholins for longer simply due to the random timing of when the process started. Or there might be some other factor we haven't identified yet, some subtle difference in surface composition or topography that makes the North Pole more efficient at trapping and processing methane. Scientists studying the New Horizons data notice something else. Mortar macula has a sharp boundary. It doesn't fade gradually from red to gray as you move away from the pole. Instead, there's a relatively distinct edge, a transition zone, where the red material stops and the neutral gray water ice of Charon's mid-latitudes begins. This suggests the cold trap mechanism is very effective. Below a certain latitude, temperatures are just slightly too warm, even by the standards of the outer solar system, for methane to remain frozen permanently. It sublimates back into space, carrying any tholins with it, or leaving them behind to be slowly buried by micrometeorite impacts. Only at the pole in the coldest regions does the methane stay put long enough to transform and accumulate. Some research suggests that similar processes might be happening on other Kuiper Belt objects. Many of them show reddish colors, particularly at their poles or in shadowed regions. Make another dwarf planet has a surface rich in tholins. Quaoar has reddish patches. Sedna shows hints of organic material. The outer solar system, far from being a sterile wasteland of ice, is actually a vast chemical laboratory, where simple molecules are constantly being broken apart and reassembled into complex structures. Charon is just one example, but it's the one we've seen most clearly. The one where we can trace the process from source Pluto's escaping atmosphere to sink Charon's polar cold trap, to transformation radiation-driven chemistry creating tholins. And there's a poetic irony in all of this. Pluto, the planet that lost its status, the world that was demoted and dismissed, is actively coloring its companion. Pluto is painting Charon, slowly molecule by molecule over billions of years. It's a gift, or maybe a mark of possession, or maybe just the inevitable consequence of two worlds orbiting so close together that their atmospheres touch. But whatever you call it, it's a connection. Pluto shapes Charon not just through gravity, but through chemistry, and Charon carries that mark openly wearing Pluto's methane as a dark red crown at its pole. Do you ever carry pieces of someone else with you, invisible but present, changed by proximity into something new? Mortar macula is also a reminder that color in the solar system often tells a story. When we see red on Mars, it's iron oxide, rust evidence of water and oxygen interacting billions of years ago. When we see blue on Earth, it's our nitrogen-oxygen atmosphere scattering sunlight. When we see yellow-white on Venus, it's sulfuric acid clouds reflecting light. Every color has a cause. Every hue has a history. Charon's red pole is the color of organic chemistry of methane, transforming under radiation of Pluto's atmosphere, reaching across space to touch its companion. It's the color of time and energy acting on simple molecules, creating complexity where none existed before. Before New Horizons, we didn't know mortar macula existed. We thought Charon was uniformly gray, and that assumption is worth examining. Why did we assume Charon would be boring? Because it's small, because it's far away, because we couldn't see it clearly. All of those reasons, yes, but also because we underestimated the solar system's capacity for diversity. We assumed that similar objects, icy moons in the outer solar system, would look similar, that they'd follow predictable patterns. But the universe doesn't care about our expectations. It creates mortar macula, a feature so specific, so unique, that it only exists on Charon, not on Pluto, not on any other moon, just there, just at that pole, just in that configuration where a world with an escaping atmosphere orbits close to a tidally locked companion with cold poles. It's a reminder that every world is its own experiment, its own story, its own combination of chemistry, physics, and history that produces something never seen before and possibly never to be seen again. Charon wears its red crown quietly. It doesn't announce itself. It doesn't glow or shimmer. From a distance, you might not even notice it. But up close, when New Horizons flew past and looked directly at the pole, there it was. Dark, red, unmistakable. A mark left by billions of years of methane arriving, freezing, transforming. A sign that even at the edge of the solar system, in the coldest, darkest places we can imagine, chemistry persists. Change continues. Beauty emerges in unexpected forms. And Charon, the quiet moon, the gray companion, turns out to be wearing something extraordinary all along. We just needed to get close enough to see it. But the pole isn't the only mystery. Beneath the red, beneath the gray ice, there are hints of something even stranger. What if a frozen moon showed signs of something that shouldn't be there anymore? Ammonia, a simple molecule. 3 hydrogen atoms bonded to 1 nitrogen atom. Common in the outer solar system, found in the atmospheres of gas, giants frozen into the crusts of icy moons. But ammonia is volatile. It doesn't stay put. At the temperatures where water ice is stable, ammonia should have sublimated away billions of years ago, escaping into space, leaving no trace. And yet, when New Horizons analyzed Charon's surface, it found ammonia. Fresh ammonia. Ammonia that had no business being there, which means something brought it up from below. If you're finding peace in these gentle drifts through distant worlds, you might want to softly press the like buttons, subscribe to continue these journeys, and ring the bell so the next quiet story can find you when the stars feel close. Now, let's descend beneath the ice. Charon's surface is mostly water ice. Spectroscopic analysis from Earth-based telescopes had told us this for decades before New Horizons arrived. Water ice reflects light in predictable ways, particularly in the infrared spectrum, creating absorption features that are easy to identify. Charon's spectrum showed those features clearly. Water ice, lots of it, covering most of the surface in a thick frozen shell. No surprise there. At Charon's distance from the sun, water ice is as hard as granite, as stable as bedrock. It doesn't melt. It doesn't sublimate significantly. It just sits there frozen solid for billions of years. But when New Horizons flew past and took high-resolution spectra of specific regions, it found something unexpected mixed in with the water ice. Ammonia hydrates. Ammonia molecules bonded to water molecules, forming crystalline structures called ammonia water ice. Not pure ammonia, which would have sublimated away long ago, but ammonia chemically locked into the ice matrix, protected from immediate escape, but still present, still detectable. The concentration wasn't huge, just a few percent by mass scattered across certain regions of Charon's surface, particularly around fractures, canyon systems, and smooth plains. But it was there, undeniably there, and that created a problem. Ammonia is volatile. At the temperatures on Charon's surface around minus 390 degrees, Fahrenheit, pure ammonia ice would slowly sublimate, turning directly from solid to gas without passing through a liquid phase. Over millions of years, it would all escape into space, molecule by molecule, leaving only the more stable water ice behind. By now, 4.5 billion years after Charon's formation, there shouldn't be any ammonia left on the surface unless it was replenished recently. And by recently in geological terms, we mean within the last few 100 million years, maybe even more recently than that. Scientists suggest this means Charon must have had some process that brought ammonia from deep inside the moon up to the surface, depositing it there in relatively recent geological history. Not yesterday, not last century, but recently enough that it hasn't all sublimated away yet. And the most likely candidate for that process is cryovolcanism, volcanoes. But not the kind we have on Earth with molten rock and lava flows. Cryovolcanoes, also called ice volcanoes, erupt with water ammonia, methane, or other volatiles instead of silicate magma. They're driven by pressure from subsurface liquids or by buoyancy differences between different ice compositions, and they occur on several moons in the outer solar system. Enceladus. One of Saturn's moons has active cryovolcanoes. Right now, geysers of water ice erupting from fractures in its south polar region, powered by tidal heating from Saturn. Triton, Neptune's largest moon, showed evidence of cryovolcanic activity when Voyager 2 flew past in 1989, plumes of nitrogen gas and ice erupting from the surface. Europa, Jupiter's ocean moon, probably has cryovolcanism beneath its icy shell, though we haven't seen it directly yet. And now, it seems Charon might have had cryovolcanoes 2 billions of years ago when its interior was still warm. Here's how it would have worked. Early in Charon's history, shortly after its formation, the interior was warm. Heat from the accretion process, heat from radioactive decay in the rocky core, possibly some residual tidal heating before the tidal lock with Pluto was complete. This heat kept a layer of liquid water beneath the frozen crust, an ocean sandwiched between the solid ice shell above and the rocky core below. And dissolved in that water, there was ammonia. Ammonia acts as an antifreeze when mixed with water. Pure water freezes at 32 degrees Fahrenheit, but water mixed with ammonia can remain liquid at much colder temperatures, down to around minus 140 degrees Fahrenheit, or even lower depending on the concentration. This makes ammonia water mixtures ideal for staying liquid in the cold environments of the outer solar system. The subsurface ocean on Charon, if it existed, was probably an ammonia water mixture kept liquid by internal heat and ammonia's antifreeze properties. Over time, as Charon's interior cooled, this ocean began to freeze. But freezing happened unevenly. Some regions cooled faster than others. Pressure built up in pockets of remaining liquid, and occasionally that pressure found a release. Fractures in the crust, weak points created by tectonic stresses, pathways to the surface. And when the pressure became too great, the ammonia water mixture erupted, bursting through the ice shell in cryovolcanic events, flooding the surface with fresh material before freezing solid in the vacuum and cold. Research shows that cryovolcanism is most effective when the erupting material has a different density than the surrounding crust. Ammonia water ice is less dense than pure water ice, which means it's buoyant. If pockets of ammonia-rich liquid exist beneath a crust of pure water ice, they naturally want to rise, seeking the surface like air bubbles rising through water. Add some pressure from freezing expansion or tectonic compression, and you have the conditions for eruption. The ammonia water mixture rises through cracks, reaches the surface, and spreads out, resurfacing the terrain with fresh material. When New Horizons scientists examined Charon's surface, they found regions that looked suspiciously smooth, lacking the heavy cratering that should exist on an ancient geologically dead world. These smooth plains, particularly a region informally named Vulcan Planitia, had far fewer craters than expected. Crater counts suggest that Vulcan Planitia's surface is relatively young, perhaps only a few billion years old, maybe younger. Something erased the old craters, something resurfaced the area, and the presence of ammonia hydrates in these regions suggests that something was cryovolcanism, liquid ammonia water mixtures erupting onto the surface, flooding the plains, freezing in place, creating smooth terrain, with fewer impact scars than the surrounding ancient highlands. It seems as though Charon, for a brief period in its early history, was geologically active, not in the dramatic way Io is active with constant eruptions and lava lakes, but active enough to resurface parts of its crust, to erase old craters, to deposit fresh material containing ammonia. And then, as the interior cooled completely, and the subsurface ocean froze solid, the cryovolcanism stopped. The ammonia stopped erupting. The surface froze into its current configuration and has remained largely unchanged for billions of years since. But here's the fascinating part. The ammonia we detect on Charon's surface today is concentrated around specific features, fractures, canyon walls, certain smooth plains. It's not evenly distributed, it's localized. This suggests the cryovolcanism wasn't a global event, but a series of localized eruptions possibly controlled by the distribution of fractures and weak points in the crust. Where the crust cracked, ammonia water mixtures could reach the surface. Where the crust remained intact, no eruptions occurred. The canyon systems we discussed earlier, Serenity Chasma and Argo Chasma, might have served as conduits for cryovolcanic material. The same tectonic forces that opened the canyons might have also created pathways for subsurface liquids to reach the surface. Erupt, freeze deposit ammonia, then stop when the interior cooled and the liquid source disappeared. Some believe this makes Charon an important piece of evidence in understanding how icy moons evolve. Charon is too small and too far from any significant tidal heating source to sustain long-term geological activity. Unlike Enceladus, which is constantly squeezed and stretched by Saturn's gravity, or Europa, which flexes under Jupiter's immense pull, Charon had only a brief window of activity early in its history. Once the internal heat dissipated and tidal locking was complete, it became geologically dead. No more volcanism, no more tectonics, just frozen silence. But the evidence of that brief active period remains. The ammonia hydrates are like fossils' chemical traces of a time when Charon's interior was warm enough to have liquid water, when pressures were high enough to drive eruptions, when the surface was young and changeable. And this raises a question. If Charon had a subsurface ocean billions of years ago, could it have supported life? The presence of ammonia complicates things. Ammonia is toxic to most Earth-based life, but it's also a useful solvent capable of dissolving organic molecules and facilitating chemical reactions. Some scientists speculate that life could theoretically exist in ammonia water environments, though it would have to be very different from terrestrial life, adapted to extreme cold and ammonia chemistry. But even if Charon's ocean couldn't support life, it was still a chemical laboratory. Liquid water dissolved minerals from the rocky core ammonia, acting as antifreeze organic molecules delivered by comets' energy from radioactive decay. All the ingredients for complex chemistry were present. Whether that chemistry ever crossed the threshold into biology, we'll probably never know. Charon's ocean is long frozen. If life existed, it died billions of years ago when the water turned to ice. But the possibility, however remote, is worth considering. Charon, the quiet gray moon at the edge of the solar system, might have once had liquid water. And wherever there's liquid water, even ammonia-contaminated water, in the frozen outer dark. There's a chance, however small, that chemistry could have become something more. Have you ever wondered what it would take for life to emerge? Not just the right chemicals, but the right time, the right energy, the right luck. Comparing Charon to other icy moons helps put its ammonia mystery in context. Enceladus, as mentioned, has active cryovolcanism right now. Its geysers erupt continuously from fractures in the south polar region, spraying water ice salt and organic molecules into space. Some of this material falls back onto Enceladus, creating smooth plains similar to Charon's Vulcan Planitia. But Enceladus has a heat source, tidal heating from Saturn, keeps its interior warm and its subsurface ocean liquid. Charon doesn't have that. Europa probably has a subsurface ocean that's still liquid today, kept warm by tidal heating from Jupiter. Its surface shows signs of recent resurfacing, chaotic terrain cracks, and ridges created by the shifting ice shell above the liquid layer below. But again, Europa has tidal heating. Charon doesn't. Triton Neptune's large moon is a captured Kuiper Belt object, similar in some ways to Charon. It shows evidence of past cryovolcanism, smooth plains, lack of heavy cratering, and spectroscopic hints of ammonia. But Triton is larger than Charon, and it might have retained more internal heat longer. It also experiences some tidal heating from Neptune due to its retrograde orbit. Charon is smaller, older, colder. It had its moment of activity and then froze completely. The lesson here is that geological activity on icy moons is largely a matter of heat. With enough heat, you get liquid water, cryovolcanism, tectonic activity, surface renewal. Without heat, you get ice craters, frozen, silence. Charon had heat once briefly, and then lost it. The ammonia hydrates on its surface are the evidence of that lost warmth. the chemical signature of a world that once had liquid beneath its crust, and then froze solid, preserving only traces of what used to be. Scientists analyzing the New Horizons data measured the spectral signatures of ammonia, hydrates in several locations. The strongest signals came from Vulcan Planitia and from regions near the large canyon systems. Weaker signals appeared in scattered patches across the mid-latitudes. The concentrations varied, suggesting multiple episodes of eruption or multiple sources of ammonia water mixtures reaching the surface. But all the detections were of hydrated ammonia. Ammonia chemically bonded to water ice, not pure ammonia. This is important because pure ammonia would have sublimated away almost immediately. Only hydrated ammonia locked into the ice matrix can persist for billions of years, slowly releasing ammonia molecules into space, but retaining enough to remain detectable. Some research suggests that ammonia might still be present beneath Charon's surface, frozen into the interior ice, waiting. If Charon were somehow reheated, if future tidal interactions or impacts delivered enough energy, the ammonia could become mobile again, driving new cryovolcanism. But that's unlikely. Charon's orbit is stable. Its tidal lock is permanent. There's no foreseeable mechanism to reheat its interior. The ammonia beneath the surface will remain frozen inert, locked away, until the sun dies and the solar system disperses. But the ammonia on the surface exposed to vacuum and radiation will continue to slowly disappear. Molecule by molecule, it will sublimate into space, escaping Charon's weak gravity, drifting away into the Kuiper belt. In another billion years, maybe less, the ammonia hydrates will be gone entirely. The surface will be pure water ice once more, and the chemical evidence of Charon's brief active period will be erased completely. We are lucky in a way to have visited Charon now, while traces of its geological past still remain visible. A few billion years earlier, and we would have seen active cryovolcanism eruptions, fresh surfaces. A few billion years later, and we would see only ancient craters, no ammonia, no hints of subsurface oceans, nothing to suggest Charon was ever anything but a cold, dead ball of ice. Timing matters. We arrived at the right moment to catch Charon in its old age, still carrying faint scars of its youth, but no longer capable of creating new ones. And there's something poignant about that, about finding evidence of warmth on the coldest moon, about discovering water that was once liquid on a world where water is now frozen harder than stone, about seeing chemical signatures of eruptions that happened billions of years ago and will never happen again. Charon's ammonia is a memory, a fossil, a whisper of heat in the endless cold. It reminds us that even at the edge of the solar system, even on moons we thought were boring and inert, there was once change, once movement, once liquid flowing beneath frozen crusts. And though that time is long past, though Charon is now silent, and still the evidence remains, written in spectral lines, hidden in ammonia hydrates, waiting for someone to look closely enough to see it. We looked, we saw, and now we know. Charon wasn't always frozen. It wasn't always dead. Once briefly it had warmth. It had liquid. It had the possibility, however faint, of something more. And that makes all the difference. But if Charon once had an ocean, if it once had liquid water beneath its crust, then how did it form? Where did it come from? What violence created this moon in the first place? How do you create a partnership that lasts billions of years? You begin with catastrophe, with collision, with something massive and fast-moving and unstoppable slamming into something else at thousands of miles per hour, shattering both scattering debris across space and hoping that gravity, patient and inevitable, can gather the pieces into something new. This is not romance. This is violence. But from that violence, Charon was born. And the story of its birth might be the most dramatic part of all. If these journeys into deep time and distant collisions resonate with you, you might gently press the like button, subscribe to keep exploring with us, and ring the bell so these stories can drift back to you when the night grows still. Now, let's witness the impact. 4.5 billion years ago, the solar system was young and chaotic. The sun had formed from a collapsing cloud of gas and dust, igniting fusion in its core and flooding the surrounding space with light and heat. Around it, the protoplanetary disk, a vast rotating cloud of rock and ice, was beginning to clump together. Gravity pulled particles into larger aggregates. Dust became pebbles. Pebbles became boulders. Boulders became planetesimals. Bodies ranging from miles to hundreds of miles across the building blocks of planets. In the inner solar system, close to the sun's warmth, rocky planetesimals dominated. In the outer solar system beyond the frost line, where water could freeze icy planetesimals, accumulated rich in water, ice methane, ammonia, and other volatiles. And in the region we now call the Kuiper Belt, far from the sun, in the cold outer reaches, thousands of these icy bodies formed, colliding, merging, growing. Pluto was one of them. Not yet the dwarf planet we know today, but a growing protoplanet, sweeping up material from its orbital path, accreting mass. And somewhere nearby, another body was forming, similar in composition, similar in size, though smaller, following a slightly different orbit, destined eventually to cross paths with Pluto. Scientists suggest that what happened next was a giant impact, a collision between Pluto and this other Kuiper Belt object. Not a gentle merger, but a violent catastrophic crash that fundamentally altered both bodies and created Charon in the process. The evidence for this giant impact hypothesis comes from several sources. First, Charon's size. As we've discussed, Charon is 1/8 the mass of Pluto, an extraordinarily large moon relative to its planet. That kind of mass ratio doesn't happen through capture, the process where a planet's gravity snags a passing object and pulls it into orbit. Capture typically results in irregular, elongated orbits and smaller mass ratios. But Charon's orbit is nearly circular, perfectly aligned with Pluto's equator, and the mass ratio is huge. This suggests a different origin, something that created Charon in place in orbit around Pluto, rather than capturing it from elsewhere. Second, the compositions. Pluto and Charon are made of similar materials, water ice and rock, but with important differences. Pluto's density is about 1.86 grams per cubic centimeter, suggesting it's roughly 60 to 70% rock by mass, with the rest being ice. Charon's density is about 1.70 grams per cubic centimeter, slightly less dense, suggesting it's closer to 55% rock and 45% ice. Charon has less rock proportionally than Pluto. This difference is consistent with Charon forming from material blasted off Pluto's icy mantle during a collision, while Pluto retained more of its dense rocky core. Third, the mutual tidal lock. Pluto and Charon are mutually tidally locked, meaning they reached a state of perfect synchronization billions of years ago. This kind of lock forms more easily when the two bodies are relatively close and have similar masses conditions that would naturally arise if Charon formed from a collision with Pluto, rather than being captured from a distant orbit. Research shows that giant impacts are common in the early solar system. Earth's moon almost certainly formed from a giant impact between the proto-Earth and a Mars-sized object scientists call Theia, roughly 4.5 billion years ago. The collision vaporized part of both bodies, ejecting a disk of molten rock and gas into orbit around Earth. That disk cooled, condensed, and eventually coalesced into the moon. The evidence is overwhelming, the moon's composition. Matches Earth's mantle, its orbit is aligned with Earth's equator, and its size relative to Earth is unusually large, though not as extreme as Charon's ratio to Pluto. Pluto and Charon likely formed through a similar process, though with ice instead of rock, and in the frozen outer solar system instead of the warm inner regions. Computer simulations of giant impacts in the Kuiper Belt support this scenario. When scientists model a collision between two icy bodies the size of Pluto and a smaller impactor, they find that the impact can eject enough material into orbit to form a large moon. The key is the impact velocity and angle. Too fast, and the impactor shatters both bodies, completely scattering debris that never reaccretes. Too slow, and the impactor merges with Pluto without ejecting significant material, but at just the right speed and angle, a grazing impact, the collision can strip material from both bodies and place it into orbit where gravity gradually pulls it together into a moon. Imagine it. A Kuiper belt object, perhaps a quarter or a third the size of Pluto, following an orbit that slowly converges with Pluto's. Over millions of years, their paths draw closer, guided by the complex gravitational interactions of the early solar system. Neptune's gravity farther in perturbs orbits. Passing planetesimals nudge trajectories. Chaos reigns in the outer solar system during this era. Nothing is stable yet. Everything is still settling. And then one day, the orbits intersect. The impactor and proto-Pluto, both moving at several thousand miles per hour, collide. The impact is oblique, not head-on, striking Pluto at an angle of perhaps 30 or 40 degrees. The force is unimaginable. Kinetic energy. The energy of motion converts instantly into heat and pressure. The surfaces of both bodies vaporize on contact. Shock waves propagate through their interiors, fracturing ice, liquefying rock. Material erupts outward, a spray of vaporized water-molten rock, shattered ice chunks, expanding into space. Some of the debris escapes entirely, flying off into the Kuiper belt, never to return. But much of it doesn't have enough velocity to escape Pluto's gravity. It enters orbit, a chaotic cloud of fragments, ranging from microscopic ice crystals to boulders miles across, circling the battered, smoking remnant of Pluto. For a while, perhaps days or weeks or months, this debris disk is hot, glowing faintly with residual heat from the impact. But space is cold. Heat radiates away quickly. The disk begins to cool, and as it cools, gravity takes over. Larger fragments attract smaller ones. Collisions occur, but gentler now, accretional rather than destructive. The debris begins to clump, to coalesce, to form a single large body, Charon. Some believe this process took only a few thousand years. Others suggest it might have taken millions. The timescale depends on how much material was ejected, how spread out it was, and how quickly collisions could merge the fragments. But either way, the result was the same: Charon, a new moon, orbiting close to Pluto, still warm from its formation, tidally interacting with Pluto's own rotation, beginning the long, slow process of mutual tidal locking. Scientists studying the simulations noticed something interesting. The impact that creates the most Charon-like moons is not the most violent impact possible. If the impactor is too large or hits too hard, it destroys Pluto completely, leaving nothing but scattered debris. If the impactor is too small or hits too gently, it merges with Pluto without creating a moon at all. The sweet spot. The Goldilocks zone is an impactor about 1/3 to 1/2 Pluto's mass, hitting at a few thousand miles per hour at an oblique angle. This strips enough material to form Charon without destroying Pluto. It's a narrow range, a delicate balance between too much violence and not enough. And somehow, in the chaos of the early Kuiper belt, Pluto and its impactor found that balance. They collided at exactly the right speed, at exactly the right angle to create the system we see today. Luck, probability, inevitability. Call it what you will. But the result is Charon. It seems as though creation and destruction are not opposites but partners. You cannot make a moon like Charon without breaking something, without shattering ice and rock, scattering it into space, and trusting gravity to reassemble it into something new. The moon around Earth was born from destruction. Charon around Pluto was born from destruction. Perhaps most of the beautiful, stable things in the universe have violent origins, hidden histories of catastrophe that smoothed over time into harmony. But there's an alternative hypothesis, one that some scientists still consider, though it's less popular than the giant impact model. Capture. The idea that Charon formed independently somewhere else in the Kuiper Belt and was later captured by Pluto's gravity. Capture happens. Neptune's moon, Triton, was almost certainly captured from the Kuiper Belt. Its orbit is retrograde, meaning it goes around Neptune backward relative to Neptune's rotation, a strong sign it didn't form in place. But capture has problems when applied to Charon. First, capturing a body as large as Charon is difficult. For capture to work, the incoming object needs to lose energy somehow slowing down enough that it can't escape Pluto's gravity. On large planets like Neptune or Jupiter, this can happen through atmospheric drag or gravitational interactions with other moons. But Pluto has no atmosphere to speak of, and no other large moons to provide gravitational assists. How would Charon slow down enough to be captured? One possibility is a three-body interaction. If Charon approached Pluto while another Kuiper Belt object was nearby, the gravitational interaction between all three bodies could steal energy from Charon, slowing it into orbit around Pluto while flinging the third body away. This can work in principle, but it requires very specific timing and positioning. The odds are low, and even if capture happened this way, it would likely result in an elongated eccentric orbit, not the circular orbit Charon has. To circularize the orbit, you'd need tidal forces acting over millions of years, dissipating energy and pulling the orbit into a circle. Possible, yes, but complicated. The giant impact hypothesis is simpler. It explains Charon's size, its circular orbit, its alignment with Pluto's equator, its composition, all in one event. Occam's razor, the principle that the simplest explanation is usually correct, favors the impact model, and most planetary scientists agree. Charon was born from violence, from a collision that shattered two worlds and reassembled the pieces into a binary system that has lasted 4.5 billion years. There's a lesson here if you want to find one. Relationships born from chaos can become stable. Systems created by destruction can find balance. What begins as catastrophe can over time become harmony. Pluto and Charon didn't choose each other. They were thrown together by cosmic accident, by trajectories that happened to intersect in the early solar system. But once together, they locked into a dance that neither has broken. They synchronized, they balanced, they became inseparable. Do you ever wonder if the best partnerships are the ones that survive the worst beginnings? The ones that start with collision and end with orbit? Comparing Charon's formation to Earth's moon helps clarify the similarities and differences. Both formed from giant impacts. Both are unusually large relative to their parent bodies. Both have circular orbits aligned with their planet's equator. But there are differences too. Earth's moon formed from the molten mantle of a rocky planet, while Charon formed from the icy mantle of a Kuiper Belt object. Earth's moon is moving away from Earth slowly, about 1.5 inches per year, because Earth's rotation is faster than the moon's orbit transferring energy outward. But Pluto and Charon are mutually locked, so there's no energy transfer, no outward drift. They're stable, frozen in their current configuration. Earth and the moon will eventually reach mutual tidal lock billions of years in the future, but Pluto and Charon have already been there for eons. They finished evolving long ago. Another comparison: Mars's moons, Phobos and Deimos. These are tiny, irregularly shaped, probably captured asteroids rather than formed from impacts. They don't compare to Charon at all. Saturn's moon Titan is large, but it's only about 2% of Saturn's mass, and it probably formed from the same disk of material that created Saturn, not from an impact. Jupiter's Galilean moons, Europa, Ganymede, Callisto, Io are all thought to have formed from the circumjovian disk around young Jupiter, not from collisions. Charon is unique. The only large moon in the solar system definitively formed from a giant impact other than Earth's moon. And unlike Earth's moon, Charon's parent body was reclassified as a dwarf planet, making the Pluto-Charon system even more unusual. a binary dwarf planet system formed by violence locked by tides orbiting at the edge of the solar system where almost no one looks. Scientists continue to refine their models of Charon's formation, running more detailed simulations, testing different impact parameters, trying to match every observable feature of the Pluto-Charon system. The density difference between Pluto and Charon, the tilt of their mutual orbit relative to Pluto's orbit around the Sun, the distribution of craters on both surfaces. Every detail constrains the model, narrows the possibilities. And the more they simulate, the more confident they become. Charon was born from a giant impact. The specifics might vary: the exact size of the impactor, the precise angle, the timing, but the basic story is solid. Violence created Charon. Chaos gave birth to order. And now, billions of years later, the evidence sits there in the cold outer dark. Two gray spheres, spinning together, holding the memory of the collision that made them. If you could rewind time, if you could watch the early solar system play out again, you'd see countless collisions. Bodies smashing into each other, merging, shattering, scattering. Most collisions created nothing of interest. Debris that dispersed. Objects that merged without drama. But a few collisions, a precious few, created something extraordinary. Earth's moon, Pluto's Charon. Perhaps other moons we don't fully understand yet. Each one a reminder that the universe builds through destruction, that creation requires breaking things apart and trusting gravity to find a new pattern. Charon didn't ask to be born. It didn't choose Pluto. It was created by an accident, a random intersection of trajectories in a chaotic young solar system. But once created, it endured. It cooled. It solidified. It locked into orbit. And it became exactly what it is now: Pluto's companion, Pluto's balance, Pluto's partner in the frozen dark. A moon born from violence, shaped by gravity, defined by proximity. A world that exists because something else broke. And in that breaking, in that scattering of ice and rock and heat, Charon found its orbit, its purpose, its place. And once Charon found its orbit, once the debris settled and the tidal forces took hold, something even stranger began. What does it mean to be connected by nothing but gravity? No atmosphere bridges them. No magnetic field links them. No light passes between them, except what reflects from the distant sun. Just gravity. Just the invisible curvature of space-time, pulling, holding, keeping them locked in their eternal rotation, 19,640 kilometers apart. Close enough to see each other clearly, far enough that they never touch. This is the relationship between Pluto and Charon. Silent, patient, unbreakable. And it's one of the most precisely choreographed dances in the entire solar system. If you're finding comfort in these explorations of connection and distance, you might want to gently tap the like button, subscribe to stay on this journey, and ring the bell so these quiet stories can return to you when you need them. Now, let's measure the space between them. 19,640 kilometers, 12,163 miles. That's the average distance between Pluto's center and Charon's center as they orbit their common Baryce center. To put that in perspective, Earth's diameter is about 12,742 kilometers. The distance between Pluto and Charon is roughly 1.5 times Earth's diameter. You could line up 1.5 Earths between them, and they'd just barely touch both worlds. That sounds like a lot. But in astronomical terms, it's nothing. Earth's moon orbits at an average distance of 384,400 kilometers. Pluto and Charon are 20 times closer to each other than we are to our moon. 20 times. If you scale down the Pluto-Charon system to the size of the Earth-Moon system, Charon would be orbiting so close to Pluto that it would be inside what we'd consider a dangerously unstable orbit for most planet-moon systems. But for Pluto and Charon, this is stability. This is equilibrium. This is where they've been for billions of years and where they'll stay for billions more. Scientists suggest that this proximity is both the cause and the consequence of their mutual tidal lock. The close distance means tidal forces are strong enough to slow both bodies' rotations relatively quickly in astronomical terms, achieving the lock within the first few 100 million years of their formation. And once locked, the system stabilizes. The distance stops changing. The orbit becomes circular. Everything freezes into its current configuration, held there by the balance of gravitational attraction and orbital angular momentum. The orbital period, the time it takes for them to complete one orbit around their common barycenter, is 6.387 days. 6 Earth days, 9 hours, 17 minutes, and 36 seconds. To be precise, that's also their rotational period. Both Pluto and Charon rotate on their axes once every 6.387 days. One rotation equals one orbit. That's what mutual tidal locking means. And because of this synchronization, they always show the same face to each other. If you stood on Pluto's surface at a location where Charon is visible, Charon would never move in your sky. It would hang there motionless hour after hour, day after day, year after year, appearing in exactly the same position above the horizon. You could build a permanent monument pointing at Charon, and that monument would always be accurate. Charon would never set. It would never rise. It would just be there frozen in place, a constant presence in your sky. And the same is true from Charon looking at Pluto. Pluto would dominate the sky, huge and gray, but completely stationary. A fixed point. A celestial anchor. Research shows that this kind of mutual lock creates unique observational conditions. From Pluto's Charon-facing hemisphere, you can always see Charon. From Pluto's far hemisphere, you can never see Charon. There's no in-between. No times when Charon peeks over the horizon for a few hours and then sets again. You're either in the Charon visible zone or the Charon never visible zone, and where you are is determined entirely by where you stand on Pluto's surface. This divides Pluto into two distinct regions. The near side, always facing Charon, always able to see it. The far side, always facing away, perpetually ignorant of Charon's existence. Imagine living on the far side of Pluto, never seeing Charon. You'd know it existed presumably through science and observation. But you'd never see it with your own eyes. It would be a theoretical moon, a concept, a mathematical prediction. To see it, you'd have to travel. You'd have to walk or drive or fly to the other hemisphere, crossing over the terminator between the Charon visible and Charon invisible zones. And only then would it appear slowly rising above the horizon as you move, growing larger as you approach the sub-Charon point. The spot on Pluto's surface where Charon sits directly overhead. Standing at the sub-Charon point would be an experience unlike anything in the Earth-Moon system. Charon would dominate the sky. At roughly 750 miles in diameter and only 12,000 miles away, Charon would appear about 8 times larger in Pluto's sky than the Moon appears in ours. It would subtend an angle of roughly 3.5 degrees compared to the Moon's half degree. That's huge. That's not a distant disk, but a nearby world close enough that you could see surface details with the naked eye, craters, canyons, plains, the dark red polar cap of Mordor macula, all visible without a telescope. And it would be motionless, utterly perfectly motionless, not slowly drifting like planets in Earth's sky, not rising and setting like the Moon, just there, always there. A silent companion watching over you unchanging across days and years and centuries. Some believe this motionlessness would be comforting, a constant in a universe of change, a reminder that some things hold. Others believe it would be oppressive, a reminder that you're locked in place, unable to experience the full cosmos, trapped in a synchronization you didn't choose. But Charon wouldn't care. Charon would just hang there, reflecting faint sunlight, casting dim shadows across Pluto's nitrogen ice plains, marking time not through movement, but through phases. Because even though Charon doesn't move in Pluto's sky, it does go through phases just like our Moon does. When the Sun, Pluto, and Charon align properly, Charon appears fully illuminated from Pluto's perspective, a full Charon. When the alignment shifts, Charon shows only a crescent with most of its surface in shadow. These phases would cycle with the same 6.387-day period, providing the only visible change in Charon's appearance from Pluto's surface. But the phase cycle wouldn't be caused by Charon moving through the sky. It would be caused by the sun's position changing as Pluto orbits it, which takes 248 Earth years. So, the phase cycle would be slow, subtle, barely noticeable over days or weeks, becoming apparent only over months. It seems as though even in perfect stillness, there is variation. Even in systems locked into rigid patterns, light and shadow create rhythm. Pluto and Charon might not move relative to each other, but the sun moves relative to both. And that's enough to create phases, eclipses, slow cycles of illumination that mark the passage of time. The distance between them, 19,640 kilometers, is stable now. But it wasn't always. When Charon first formed from the debris of the giant impact, it was likely much closer to Pluto, orbiting at perhaps half the current distance, maybe even closer. Tidal forces were immense at that proximity. Pluto's gravity created enormous bulges in Charon's molten or semi-molten surface, and Charon's gravity did the same to Pluto. These tidal bulges acted like friction, slowing both bodies' rotations and transferring energy from rotation into orbital motion. Over millions of years, this process pushed Charon farther from Pluto, widening the orbit while simultaneously slowing both rotations until they matched the orbital period. Eventually, the system reached a stable configuration where the tidal forces balanced perfectly and the outward migration stopped. That's where they are now, at the equilibrium distance where mutual tidal lock is stable and no further energy transfer occurs. Scientists studying tidal evolution in binary systems calculate that once mutual lock is achieved, the orbital distance becomes essentially frozen. There's no more energy to transfer. Both bodies are rotating at the same rate as their orbit, so there's no differential motion to create tidal friction. Pluto and Charon will stay at their current distance, 19,640 kilometers apart, for billions of years. Possibly forever, or at least until some external force, a close encounter with another Kuiper belt object, or the distant future when the sun becomes a red giant, disrupts the system. Comparing this to the Earth-Moon system highlights the difference between systems that have reached mutual lock and systems that haven't. Earth and the Moon are tidally locked in one direction. The Moon is locked to Earth, always showing us the same face. But Earth is not locked to the Moon. Earth still rotates much faster than the Moon, orbits completing one rotation every 24 hours, while the Moon takes 27.3 days to orbit. This mismatch means tidal forces are still acting, still transferring energy. The Moon's gravity creates tidal bulges in Earth's oceans, and as Earth rotates beneath these bulges, friction slows Earth's rotation slightly. The energy lost by Earth is gained by the Moon, which uses it to move into a higher, farther orbit. The Moon is currently moving away from Earth at about 1.5 inches per year, or 3.8 centimeters. This has been measured directly using laser reflectors left on the Moon's surface by Apollo astronauts. We shine lasers at the Moon, measure how long the light takes to return, and calculate the distance with incredible precision. And year after year, the distance increases. Eventually, billions of years from now, Earth's rotation will slow enough that it matches the Moon's orbital period and Earth will become tidally locked to the Moon. At that point, the energy transfer will stop and the Moon will stop drifting away. Earth and Moon will have reached mutual tidal lock, just like Pluto and Charon. But that day is unimaginably far in the future, long after the sun has exhausted its hydrogen and begun its death throes. Pluto and Charon reached this point billions of years ago. They're ahead of us, finished evolving, while Earth and Moon are still in progress. Do you ever wonder what it would be like to reach a final state, to stop changing? To find a balance so perfect that nothing more needs to happen? The gravitational force between Pluto and Charon can be calculated using Newton's law of universal gravitation. The formula is simple force equals the gravitational constant times the product of the two masses divided by the square of the distance between them. Plug in Pluto's mass 1.3, 0.3 times 10 to the 22nd kilograms, and Charon's mass 1.5, 86 times 10 to the 21st kilograms, and the distance 19,640 kilometers, and you get a gravitational force of roughly 3.5 times 10 to the 18th newtons. That's a massive force by human standards, but in astronomical terms, it's perfectly balanced by the centrifugal force of their mutual orbit. They pull on each other with enormous strength, but that pull is exactly countered by their orbital motion, creating a stable equilibrium where neither falls into the other nor flies apart. This balance is gravity's poetry, attraction without collapse, connection without collision. Two objects pulling on each other across empty space, neither winning, neither losing, just holding each other in perfect opposition. Scientists studying the Pluto-Charon system use it as a natural laboratory for understanding tidal locking binary dynamics and orbital mechanics. Because the system is so simple, just two bodies with no other significant gravitational influences, no large third body perturbing the orbits, no complex resonances with other moons. It's easier to model than more complicated systems, like Jupiter's moons or Saturn's rings. Pluto and Charon are a textbook example, a clean, clear demonstration of how tidal forces work, how mutual locks form, how binary systems evolve. And the data from New Horizons has allowed scientists to refine their models even further, measuring Charon's exact mass, its density, its shape, all the parameters needed to build accurate simulations. One of the surprising findings from New Horizons was just how spherical Charon is. Despite its relatively small size and low gravity, Charon is almost perfectly round, with only slight deviations from a sphere caused by its rotation and tidal bulge toward Pluto. This suggests that early in its history, Charon was warm enough and soft enough to flow into a spherical shape under its own gravity, a process called hydrostatic equilibrium. Only bodies with enough mass and internal heat can achieve this. Smaller objects like asteroids or Mars's moons remain irregular and lumpy because their gravity isn't strong enough to reshape them. But Charon, despite being smaller than Earth's moon, managed to become round. This tells us it had significant internal heat shortly after formation, possibly from the energy of the giant impact that created it, possibly from radioactive decay in its core, possibly from tidal heating during the early phases of orbital evolution before the lock was complete. That heat allowed Charon's interior to soften, to flow to settle into a spherical shape. And then, as the heat dissipated and the interior froze solid, the shape locked in, preserved for billions of years. Some research suggests that this early warm period is also when Charon had its subsurface ocean, the ammonia water layer we discussed earlier. The timing lines up. Shortly after formation, Charon was warm, soft, partially liquid. It had an ocean, it had geological activity, it had cryovolcanism. And then, over the next billion years or so, it cooled, the ocean froze, the volcanism stopped, the surface solidified into the ancient cratered canyon-scarred terrain we see today. The distance between Pluto and Charon watched this entire process unfold. It started smaller, with Charon closer to Pluto, tide stronger, rotation faster. And then, as the tidal lock approached, the distance gradually increased to its current value and stopped. 19,640 kilometers. The final separation. The equilibrium point. The place where they'll stay until something catastrophic changes the system, and what could change it. Not much, honestly. The Kuiper Belt is vast and mostly empty. Collisions are rare. The chances of another large object hitting Pluto or Charon hard enough to disrupt their orbit are astronomically low, though not zero. Over billions of years, improbable events become possible. A rogue Kuiper belt object could pass close enough to perturb the system, gravitationally adding or subtracting energy, changing the orbit slightly. But even that would likely just shift the distance a bit, not break the lock entirely. Pluto and Charon are gravitationally bound so tightly that separating them would require enormous energy, more than any plausible collision or encounter could provide. They're together, permanently. Barring the end of the solar system itself, they'll remain as they are, two gray worlds spinning around a point in empty space, 19,640 kilometers apart, forever showing each other the same face, forever locked in their silent dance. It seems as though some relationships once formed are unbreakable, not because they're perfect, but because they've found a balance that requires no further adjustment, no more energy to transfer, no more changes to make, just existence, just presence, just the quiet, patient holding of orbit across empty space. And in that holding in that distance maintained across billions of years, there's something profound. Something that transcends physics and touches poetry. Two worlds neither large by cosmic standards, neither important in the grand scheme of the galaxy, finding each other in the chaotic early solar system, and deciding through the impersonal mathematics of gravity to stay together. Not because they had a choice, not because they wanted to, but because their trajectories intersected at just the right moment, at just the right speed. And gravity did what gravity does, pulled them together and held them there. 19,640 kilometers. Not too close, not too far, just right. The space between them is filled with nothing but vacuum radiation and the invisible curvature of space-time. But that nothing is everything. That emptiness is connection. That distance is relationship. And it has lasted longer than continents, longer than species, longer than anything we can imagine on human timescales. And now, as we near the end of this journey, it's time to ask what it means to exist at the edge of everything, watched by no one holding on to each other in the frozen dark. We've traveled far tonight, nearly 4 billion miles from home. We've descended into canyons deeper than anything on Earth. We've examined red polar caps painted by chemistry and time. We've traced the scars of ancient oceans frozen beneath impenetrable ice. We've witnessed the violence of formation, the patience of tidal, locking the mathematics of gravity stretched across empty space. And through it all, Pluto and Charon have been there spinning quietly in the outer dark, holding each other across 19,640 kilometers of nothing, doing what they've done for 4.5 billion years, existing, orbiting, being exactly what they are. But now, at the end of this journey, we need to step back, to see them not just as geology and chemistry and orbital mechanics, but as something else, as watchers at the edge, as companions in the deepest cold, as proof that even at the boundary of everything, we know nothing has to be alone. Pluto and Charon orbit the Sun at an average distance of roughly 5.9 billion kilometers, 3.7 billion miles, 39.5 astronomical units, where 1 astronomical unit is the distance from Earth to the Sun. At that distance, sunlight takes 5.5 hours to arrive. When you see the Sun from Pluto's surface, you're seeing it as it was 5.5 hours ago. Light that left the Sun mid-morning reaches Pluto in mid-afternoon Earth time. There's no real-time connection, no instant communication, just photons crawling across the vast emptiness between the Sun and the edge of its influence. And when those photons finally arrive at Pluto, they're weak, incredibly weak. The Sun appears roughly 1,600 times dimmer from Pluto than from Earth. It's no longer a blazing disk dominating the sky. It's just a very bright star, brighter than anything else. Yes, but still just a point of light among countless others. Venus from Earth appears brighter than the Sun appears from Pluto. Think about that. The Sun, our star. the source of all light and heat and energy in the solar system, reduced to something dimmer than a planet seen from Earth. That's how far Pluto and Charon are from the center of things. That's how isolated they are. Scientists suggest that this isolation defines much of what Pluto and Charon are. Without the sun's warmth, their surfaces remain frozen at minus 390 degrees Fahrenheit, or colder. Without frequent collisions from asteroids or comets, their surfaces age slowly, preserving ancient features for billions of years. Without strong solar wind or radiation, their thin atmospheres and surface chemistry evolve at geological time scales, changing so slowly that a human lifetime would capture almost no difference at all. They are removed from the chaos of the inner solar system. No volcanism driven by solar heating. No atmospheres thick enough to create weather. No plate tectonics recycling crusts, just ice rock vacuum and time. And in that removal, in that isolation, there's a kind of peace, a stillness that the inner planets with their dynamic atmospheres and active geology and constant change can never know. Pluto and Charon have reached equilibrium. They've settled into their final forms. They're not evolving anymore, not in any significant way. They're done, finished, and they're content to simply be spinning together in the silence, waiting for nothing, expecting nothing, just holding their orbit as the eons pass. But they're not entirely alone, not quite, because on July 14, 2015, something visited them, something human. The New Horizons spacecraft launched from Earth in January 2006 traveled for 9.5 years across the solar system to reach Pluto and Charon. 9.5 years of silence. 9.5 years of empty space. The spacecraft was about the size of a grand piano, weighing roughly 1,000 pounds, powered by a plutonium battery, because solar panels would be useless so far from the sun. It carried 7 scientific instruments, cameras, spectrometers, plasma detectors, dust counters, and it was moving fast, 36,000 miles per hour relative to Pluto. Too fast to stop, too fast to enter orbit. Just a flyby, a brief encounter, a few hours of observation as it screamed past at interplanetary speed. The closest approach happened at 7:49 a.m. Eastern Daylight Time on July 14th. New Horizons passed within 7,750 miles of Pluto's surface, close enough to see details smaller than football fields, close enough to measure surface composition, atmospheric density, temperature, magnetism, everything. And then it continued past Charon, capturing images and data from that moon too, before flying onward into the Kuiper Belt, never to return. It was humanity's first and only visit to Pluto and Charon, and it will likely be our last for decades, possibly centuries. No other missions are planned, no other spacecraft are on their way. New Horizons was it. A single pass. A few hours of intense observation, and then silence again. Research shows that the data from New Horizons is still being analyzed today, almost 10 years after the flyby. Scientists are still discovering new details in the images, still refining their models of Pluto and Charon's geology and chemistry, still writing papers based on measurements taken in those brief hours. Every pixel of every image contains information. Every spectral line tells a story. And slowly, carefully, the scientific community is extracting those stories, piecing together a fuller picture of what Pluto and Charon are, how they formed, what their surfaces are made of, what their interiors might contain. But no matter how much we analyze the data, we can't go back. We can't take more pictures from different angles or land on the surface or drill into the ice. New Horizons flew past and kept going, and now it's billions of miles farther out, heading deeper into the Kuiper Belt, studying other objects, sending back data when it can. Pluto and Charon are behind it, receding, growing more distant every second. And from their perspective, if they had perspective, humanity visited for a moment and then vanished. A metal object appeared from the direction of the inner solar system, lingered briefly, flashed some instruments at them, and then disappeared into the outer dark. Did it change them? No. Did it matter to them? No, they don't know we exist. They don't know we looked at them, studied them, named them, wondered about them. They just continue their dance, oblivious, indifferent, eternal. And there's something humbling about that. Something that puts our existence into perspective. We built New Horizons, we launched it from Earth. We guided it across billions of miles of empty space with incredible precision, timing, the trajectory, so it would arrive at exactly the right place, at exactly the right time to observe Pluto and Charon. That's an astonishing achievement, a triumph of engineering, mathematics, patience, and human curiosity. But from Pluto and Charon's perspective, it was nothing, a speck of metal passing by, a momentary presence that left no trace. They didn't notice, they didn't care, and they'll continue spinning together long after humanity is gone, long after Earth has been consumed by the dying sun, long after every trace of our civilization has vanished. That's not depressing, that's profound. It reminds us that the universe doesn't revolve around us, that there are places and processes and partnerships that exist entirely independent of human observation, human understanding, human meaning. Pluto and Charon were there before we looked at them. They'll be there long after we stop looking. And their dance, their partnership, their silent relationship across 19,640 kilometers of empty space doesn't need us to validate it or understand it or give it meaning. It just is. Some believe this is why we explore, not to conquer or claim or colonize, but to witness, to see things that exist without us, to acknowledge that the universe is vast and full of wonders that don't care whether we notice them or not. New Horizons gave us that gift. It let us see Pluto and Charon clearly for the first time. It showed us the canyons, the red poles, the smooth plains, the ancient craters. It gave us data and images and measurements, and then it left, allowing Pluto and Charon to return to their isolation, their silence, their endless rotation in the frozen dark. Do you ever feel like some things are beautiful precisely because they don't need you, because they exist independent of your gaze, your understanding, your presence? Standing on Charon's surface, if you could stand there, if you could survive the cold and the vacuum, you would see Pluto dominating the sky. Huge, gray, motionless, covering roughly 3.5 degrees of the sky, 8 times larger than the moon appears from Earth. You could see its features with the naked eye, the pale heart-shaped region of Tombaugh Regio, the darker equatorial band, the mottled patterns of nitrogen ice plains and methane frost. And Pluto would never move. Hour after hour, day after day, it would hang there fixed in position, a constant companion watching over you in the endless night. The sun would be a bright star far in the distance, providing just enough light to see by, but no warmth, no comfort, no sense of connection to the inner solar system where Earth orbits in relative luxury. And the stars would be glorious, with no atmosphere to blur them, no light pollution to wash them out. The stars would shine with perfect clarity, thousands upon thousands of them. The Milky Way stretched across the sky like a river of light, dense and detailed and overwhelming. You would see stars that are invisible from Earth. You would see the galaxy as our ancestors saw it, before cities and electric lights erased the night. And you would be alone, completely alone. The nearest other humans, if any existed, would be billions of miles away on Earth, their light and radio signals taking 5.5 hours to reach you. No real-time conversation, no instant communication, just delay, just distance, just the knowledge that you are farther from home than any human has ever been standing on a moon at the edge of the solar system, watching a dwarf planet that was born from violence and cooled into stillness billions of years ago. It seems as though isolation, when chosen or accepted, can be a form of freedom, a release from the noise and heat and chaos of the center. Pluto and Charon don't have to compete with Jupiter's storms or Saturn's rings or Mars's dust devils. They don't have to endure the sun's glare or the solar wind's pressure. They're out here in the quiet, in the cold, doing their thing, spinning, holding each other, marking time not through change, but through persistence. And maybe there's a lesson in that. Maybe not every story needs to be about transformation or growth or progress. Maybe some stories are just about enduring, about finding your orbit and holding it, about being what you are without apology or ambition. Pluto and Charon aren't trying to be anything other than what they are. They're not striving for relevance or importance. They're just there, and that's enough. But we as humans struggle with that. We want meaning. We want purpose. We want to matter. And so we look at Pluto and Charon and we project our own needs onto them. We see partnership. We see resilience. We see beauty in the frozen dark. We create narratives about their relationship, their history, their significance. And those narratives help us. They give us comfort. They remind us that connection is possible even in the coldest, loneliest places. That partnership can endure across impossible distances. That gravity silent and invisible is enough to hold two worlds together for billions of years. But Pluto and Charon don't need our narratives. They don't need our meaning. They're not here for us. They're here for themselves, if such a phrase even makes sense for objects without consciousness. They exist because they exist. They orbit because gravity demands it. They hold each other because the mathematics of their formation and evolution left them no other option. And in that deterministic, mechanical, utterly impersonal relationship, we see poetry. We see love. We see something that transcends physics and touches the human heart. Because we need to believe that connection matters, that holding on matters, that even in the vastness of space, even in the deep, cold billions of miles from the sun, two things can find each other and stay together. And Pluto and Charon, whether they know it or not, give us that belief. They are proof, not of love because they cannot love, but of persistence, of stability, of the idea that once you find your orbit, once you lock into synchronization with something else, you can hold that position indefinitely. You can outlast everything. You can endure. Scientists will continue studying Pluto and Charon for decades to come. New data might arrive if another mission is someday approved and launched, though the day seems distant. But even without new missions, the data from New Horizons is rich enough to fuel research for generations. Every crater tells a story about impacts. Every canyon tells a story about tectonic forces. Every spectral line tells a story about chemistry. And slowly, patiently, we'll extract those stories, build our models, refine our understanding. But the essential truth will remain the same. Pluto and Charon are two worlds gray and cold, spinning together at the edge of the solar system. They've been doing this for 4.5 billion years. They'll continue doing it for billions more, and nothing we discover will change that. Nothing we learn will alter their dance. We are observers, witnesses, temporary visitors to a relationship that was ancient before we existed and will continue long after we're gone. And maybe that's the real gift of exploration, not control or mastery or understanding, but perspective. The ability to see something that doesn't revolve around us, to witness a universe that functions perfectly well without human input, to realize that we are small, temporary, insignificant in the grand scheme of cosmic time and space. And yet, despite that insignificance, we still reach out. We still build spacecraft and send them billions of miles to see things that don't need to be seen. We still ask questions about moons that don't care about the answers. We still search for meaning in the frozen dark. Because that's what humans do. We witness, we wonder, we tell stories. And in those stories we find connection. Not just to Pluto and Charon, but to each other. To the engineers who built New Horizons. To the scientists who analyzed the data. To the people who looked at the images and felt something shift inside them, some recognition that the universe is vast and strange and full of partnerships we never expected to find. Charon and Pluto are watchers at the edge, silent guardians of the outer dark, companions in the cold, And though they'll never know we visited, they'll never care that we study them and name their features and wondered about their origins. They've given us something precious. They've shown us what it means to hold on, to find balance, to dance together in the silence for billions of years without faltering, without failing, without letting go. We've drifted through canyons and chemistry, through impacts and ice, through distances measured in kilometers and time measured in eons. We've seen a moon that isn't quite a moon, a planet that isn't quite a planet, a relationship that defies easy categorization. We've learned that boring is a failure of imagination, that isolation can be peaceful, that violence can create beauty, that gravity patient and invisible is the strongest bond in the universe. And now, as this journey ends, as we prepare to leave Pluto and Charon behind and return to our own world, our own orbit, our own warmth and light and noise, take a moment to remember them. Two gray spheres spinning slowly in the outer dark, showing each other the same face forever, holding each other across empty space, dancing alone where no one watches, where the sun is just a distant star, where time moves slow and cold and patient. They'll be there long after we're gone, still dancing, still holding, still being exactly what they are. Thank you for drifting with me through the frozen silence, for witnessing this partnership at the edge of everything, for letting curiosity carry you billions of miles from home to see two worlds that don't need us, but somehow inexplicably move us anyway. If these stories bring you peace, bring you wonder, bring you a sense of connection to the vast cosmos we inhabit, then they've done their work. And there are more stories waiting, more moons and planets and asteroids and mysteries scattered across the solar system and beyond, more quiet journeys to take, more wonders to witness, more questions to ask in the darkness. Until we drift together again, sleep well, dream gently, and remember that even at the edge of everything, even in the deepest cold, nothing has to be alone. Good night,